A confirmation for the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm. Thank you. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep. Welcome to another session of Indian Geography, where today we shall be moving ahead with a portion of soil, as well as we shall be entering into the area of economic geography, that is the portion of agriculture today. I hope that overall the preparation is going well. I hope you guys are able to revise and you are able to pay and give adequate amount of justice to the areas that you have studied. And anywhere or in any particular portion, if you are facing any issue which is persistent, feel free to contact us, and always feel free to get in touch with us, and we can help you. We shall help you in any which way as possible. Having said that, what is it that we looked at yesterday? So, yesterday we looked at the river systems of the country, the various different river systems in the Himalayan region, as well as the peninsular river systems. And then after that, we also took a look at the aspect of the forests. We understood the latest portion of the current affairs there as well. So not only did we take a look at the different types of forests that we find in the country, we took a look at the conditions required, as well as the example of the species of the various different types of trees. That becomes relevant from the point of view of examination, as we saw with the couple of PYQs as well, that where is it that, or what kind of questions can be asked from there. And then after that, we entered into the portion of soil. Okay. Now, here, today we shall be taking a look at the major types of soil that we have in our country. Now, of all the various different types of soil, you don't need to start delving into detail into each and every type of soil types. That is not relevant for your exam. Overall, you have to understand that when you are studying for soil, there are 3 to 4 major soil types which are going to be important from your examination point of view. And that is what UPSC also keeps on asking. So when we say important for your examination, so let's say important for exams. So here, alluvial soil. In the case of alluvial soil, we have already seen, in the case of when we were discussing about the physiography, we have already seen that alluvial soil is classified into 2 types broadly. You have the Khadar, that is a newer alluvium, as well as Bhangar, which is constituted of the older alluvium. That is something we have seen. Then black soil. Then red and yellow soil. And then after that, laterite soil. Okay, these are the areas, these are the types of soil that you need to be concentrating upon. These are the types of soil that you need to be looking into. Okay, other than that, the other soil types not very relevant for your examination. These are the ones which have been asked in the prelims. In the mains, you generally don't find a question at this level, that is the level of civil services. You don't find a question at the level of civil services to be asking that describe all the various types of soil that you have. Such kinds of questions UPSC generally does not ask, because such types of questions generally are up to the level of class 7th, 8th, 9th, and 10th. So such types of questions you shouldn't expect in the examination. So you can get prelims type of question from here. So these are relevant for your prelims exam. Okay. Now, when we talk about the various different types of soil, here Each of the soil type will have its own characteristic, its own nature in terms of the presence of various different nutrients that you end up finding in the soil, right? All the different soil types will have the presence of different macro and micronutrients as well. Now, for example, when we talk about the major nutrients which should be present in the soil and the major nutrients which end up determining the plant growth, so the macronutrients overall are what? They are nitrogen, phosphorus, and potassium. These are the various major nutrients required by the soil. And the availability of these nutrients ends up determining whether the soil is fertile or not. In case a particular soil lacks any of these nutrients, that is when you add any kind of an additional input like fertilizers, and fertilizers of various different categories of various different kinds are added. And it is ideally advised that the mixture of the added input should always be in the ratio of 4:2:1. 4:2:1. This is also your very famous NPK ratio. Okay. 4:2:1 means for every unit of potash that you put in, you should put in 2 units of phosphate and 4 units of nitrogen. Now, generally you will find that all the soil types of the world, they are very, very poor in nitrogen content. They don't have nitrogen. Majority of the soil types in the world, they lack nitrogen. And what is the reasoning for that? We studied this under the portion of climatology as well. What do you think is the reason why almost all the soil types of the world, they are poor in nitrogen content? Very good, Vipin. Avni, good. Kirtana, good. All of you. Very nice. That is because amongst all the major different gases that we have in the atmosphere, nitrogen is very predominant, but it does not readily react with any kind of a surface, be it a rock type or anything else. So that is why, because of the inertness of nitrogen as a gas, that is why it does not readily react. So you don't have nitrates in the form of the rocky surfaces. Generally, you will find they are not particularly rich in nitrates and nitrogenous compounds. So the soil is formed as a result of what? As a result of the disintegration of these various different types of rocks. So if the rocks are poor in nitrogen, obviously the soil will also be poor in nitrogen. So here, always understand major soil types, most of the soils are poor in nitrogen. No, nitrogen is not a noble gas. Most of them are poor in their nitrogen content. So that is why you need to add a kind of a nitrogen supplement. And for that, in order to supply nitrogen, you apply, or the fertilizer which is applied is urea, which is always applied quite significantly and in large bulks and large quantities. Now, because of the fact that the urea and other fertilizers are provided at a subsidized rate, that also brings about a kind of a practice where anything which is available on a cheaper rate, we tend to apply it more, isn't it? If you increase the price of urea, obviously the farm input cost is going to increase, but because it is available at such a cheaper rate, the farmers, they keep on adding significant amount of nitrogen to the soil. And eventually, if you overload the soil with any kind of a fertilizer, it becomes infertile, right? Even though the counterintuition is something different. The counterintuition is that the soil will require nitrogen, so let us add 50 kgs of nitrogen or urea in that. But that makes the soil infertile. And that infertility is being observed in majority of the farmlands across the country. and that is because of excess application of these nutrients, excess application of these fertilizers. Okay, now here, when we talk about it, India has varied relief features, landforms, climatic realms, and vegetation types, as a result of which the types of soil also end up varying. So here, when we take a look at it, basically, the most predominant soil type that we have is the alluvial soil, which covers close to around 40% of the total area. Okay, so alluvial soil, that is the most predominant of the soil type that you find, and overall across the country covers 40% of the area. So how is it that this alluvial soil is created? So this is basically a result of deposits, depositional action carried by the flowing water or running water or rivers. They are the major source of creation of this alluvial soil. So here, basically, a result of depositional action Okay, so alluvial soils are a result of the depositional action, and wherever you have the river systems which are in existence, they end up creating these kinds of deposits and these kinds of depositional features as well. So when we talk about it, where is it that you find these alluvial soils? Where is it that you will find this kind of a deposit to be in existence? All around the region, when we talk about the northern plains, right from the region around Punjab, Haryana, Western UP, the central portion of Uttar Pradesh, then you have Bihar, portions of Jharkhand, portions of Madhya Pradesh, then even West Bengal, Assam. So this entire belt from Punjab to Assam, that is consisting of alluvial soil. Also, you have small rivers and riverine systems which originate from the region of Aravallis in the region of Rajasthan. So there is a presence of this alluvial deposit in the Rajasthan Gujarat belt as well. There also you will find the presence of alluvial soil. Other than that, across the coastal plains, there also the rivers will carry out its deposit, the deltaic stretches, the deltas which are created, the coastal plains which are created. So there also we find the presence of alluvial soil to be there. So in all these areas, we find the presence of alluvial soil. So rather than learning and by hearting the regions where alluvial soil is formed or found, you can always derive at that particular solution by your logic. Okay, so apply your logic in that case, that will be more than sufficient here. So the entire northern plains are made up of alluvial soil and also extend in Rajasthan and Gujarat through a narrow corridor. Eastern coastal plains, particularly the deltaic stretches of Mahanadi, Godavari, Krishna, Kaveri, and also in the region of Malabar plains. In certain areas of Malabar plains, there also you will find, where is Malabar plains? In the region of Kerala. So eastern coastal plains and also Malabar plains. Okay, so that is where you will find the presence of alluvial soil. Now, alluvial soil has been formed as a result of deposit. And yesterday we had talked about it, that because it has been carried out as a result of deposit, so obviously it is going to be enriched with minerals and nutrients on a regular and a timely basis. So this is a particular soil which is fertile. And also here you will find that you also have the presence of organic nutrients in certain parts, right? So in certain parts you will find the presence of organic nutrients as well. So for example, these are depositional soils transported and deposited by rivers and streams of three important Himalayan rivers, that is Indus, Ganga, and the Brahmaputra. These are the major rivers which carry out this deposition. That is why from the region of Punjab, Haryana, Uttar Pradesh, Madhya Pradesh, northern part of Madhya Pradesh, Bihar, some parts of northern Jharkhand, significant portion of West Bengal, and even Assam. Okay. Now, according to the age of the alluvial soil, they can be classified into older alluvium, that is Bhangar, as well as the newer alluvium, that is Khadar. Obviously, the newer alluvium, that is going to be more fertile. This is going to be more fertile. In the older alluvium, you will have the presence of slightly larger granules because of the calcification which happens, and we studied that in the portion of physiography, that calcification creates what is referred to as conchers. So in the older alluvium, you will find crops such as maize, millets, pulses, grams, some types of oil seeds. These are the major crops which are grown. Whereas in Khadar, almost all kinds of crops can be grown in this area. Almost all crop types. Right? They can be grown in the newer alluvium. So it is going to be rich in potash, phosphoric acid, and lime, whereas it is going to be significantly poorer when it comes to the presence of nitrogen. And that is the case in almost all the soil types. So observe here where you find the presence of alluvial deposits. So in the entirety of the stretch, wherever we have the northern plains, in that entirety of the stretch, observe you have these alluvial soil deposits. Across the plain areas as well, wherever you have the deltas, there also you will find the presence of alluvial soil. And the thin strip from Rajasthan all the way to Gujarat, there also you'll find the presence of alluvial soil. So that is where you have the significant presence of alluvial soil. In fact, if you take a look at this particular map carefully, you will be able to understand the various different soil types just by knowing the physiography. For example, when we talk about the peninsular part of the country, it is composed of igneous and metamorphic rocks. Now, these igneous and metamorphic rocks generally, under normal conditions, other than the basaltic lava, when that disintegrates, we have the creation of black soil. So observe, you have the presence of black soil in the entire region from the Deccan Traps to some part of the Malwa Plateau. You have the presence of black soil. Otherwise, you have the presence of the red and yellow soil. So that constitutes the entirety of the peninsular part of the country. Okay, we will take a look into it as we move further, as we move ahead. Okay. Now, they are ideal for growth of sugarcane, paddy, wheat, and other cereal and pulse crops. Due to its high level of fertility, regions of alluvial soil are intensively cultivated and densely populated. Intensively cultivated means what? That means each and every part, each and every area that is brought under cultivation here. Each and every part, right? So rarely will you find an area in this alluvial tract region which is left barren, where you have the presence of alluvial soil, but it is still barren. Most of them have been brought under cultivation. So here you will find the population also to be very high. In all the regions of the alluvial soil, that is a kind of an economic aspect that you can think about, that because each and every area is so very fertile, that is why you will have a high density of population here. And generally, if each and every area is to be cultivated, what do you think will be the size of the farmland? Will the size of the farmland be very large, or will the size of the farmland be small in general? Very good. Beautiful. So in this case, mostly other than the region of Punjab, Haryana and some parts of Western Uttar Pradesh. Other than that, in the entirety of the stretch, you will find that the size of the land holdings are particularly small. It is very fragmented. It is very, very small. So majority of the farmers in this area, they belong to the small and marginal category, as we will study when we enter into agriculture. Then we come across black soil. Black soil is formed as a result of disintegration of the flood basaltic lava which has emerged or which erupted during the creation of the Deccan Traps. So formed as a result of disintegration or weathering of basaltic lava. So that is why here again the characteristics and the attributes of the parent rock that becomes particularly predominant and particularly important in determining the type of soil and the characteristic of the soil as well. Now this black soil generally you'll find has got very small granules, very small grain size. So here the grain size is very small. Grain size is very small. Now, if the grain size is small, what can we say about the water holding capacity? Will it be able to retain water or will it be losing water very easily? Very good. It will have a higher water retention capacity. Vipin, yes, not only River Luni, but also the presence of certain other smaller temporary streams. So you have Mahi also in that region, Sabarmati also in that region. So all of them, they end up attributing to that alluvial soil in Rajasthan and Gujarat. So in this case, as the grain size is small, the water holding or the water retention capacity is high. Okay, that is basically a characteristic. Krishna, black soil is also formed by disintegration of basaltic igneous rocks. My dear friend, when I say basaltic lava, please don't get confused that molten lava in itself will form the black soil. This basaltic lava is what creates igneous rocks. Let me write it down so that you don't get confused here. Okay, basaltic igneous rocks. Okay, I hope now there is no doubt, right? Okay. So these things should be understood naturally. So lava cannot lead to formation of soil automatically. Lava will basically end up creating rock, and that rock over a period of millions of years, that will get disintegrated into soil types. Now here, this is primarily used for cultivation of cotton. That is why it is also sometimes referred to as the black cotton soil. It is also known as regur soil and is ideal for growing cotton and is also known for black cotton. Not that in this region you don't have any other crops. Groundnuts are also grown in this area. In certain area, millets are also grown. In many areas, paddy or rice is also cultivated. But it is typically known for cotton cultivation. That is the prime USP of this. Okay. Now, yes, sugarcane is also to be grown in this area. Now here, climatic conditions along with the parent rock material, they are the important factors for the formation of the soil. Now we have seen that it has got very fine particles, very small particles, right? So imagine this soil type which has got very fine particles. Now during the dry season, availability of water is generally going to be less, right? So let's suppose in this region you have slight availability of water here. Now, as the grain size is particularly small and you have the availability of water in some portion, obviously the other granules, the other grains, they will start sticking around it. They will start sticking around the presence of moisture. So as a result of that, during the dry season, they open up cracks on the surface. They develop cracks on the surface. Now, the development of these cracks happens as the soil consolidates around any kind of moisture which you find. And that is when these large cracks, they allow for natural penetration of air to the lower regions. And that is what you carry out when you carry out the plowing purposes and the plowing activities. That is what you do. Why do we carry out plowing? So we plow the land. Why? So that air is allowed to go into the lower reaches as well. That is why we allow the plowing activities. We carry out the plowing activities. In this case, naturally, that crack develops, which allows the penetration of air to the lower depth. And that is why this soil is also referred to as the self-plowing soil. So this soil has got the characteristic of self-plowing. Okay, now here, what do you think can be the or what do you think will be the proportion of organic components? Will this soil be rich in organic components or poorer in organic components? What do you think? Think about it, how it is formed. Very good. It is going to be poor, right? Because it is formed as a result of disintegration of igneous rocks. And igneous rocks, they don't have organic component. So if the soil created as a result of the igneous rock will also be poor in organic component. So generally you will find these soils to be poor in organic content. So here, typical of Deccan Trap region, spread over the northwest Deccan Plateau, made up of lava flows, also to be found in the region of Malwa Plateau as well. The plateaus of Maharashtra, Saurashtra, Malwa, Madhya Pradesh and Chhattisgarh, and extends in the southeast direction as well along the Godavari and Krishna valleys, that is around the region of Telangana, northern parts of Karnataka. There also you will find the presence of this soil type. And here it is rich in calcium carbonate, magnesium, potash, and lime, whereas it is poor in phosphoric content, nitrogen, as is the case, and also organic matter. This is poor in organic component as well, right? So that is where this soil has certain nutrients. It is still considered to be amongst the fertile soil because certain micronutrients that you have, that is present in the soil. But amongst the macronutrients, you do need to add in various fertilizers and inputs. So observe the development of these large cracks. That is observed especially during the dry season and the dry condition. So during the dry season, these soil develop wide cracks which help in proper aeration of the soil. Thus, there occurs a kind of a self-plowing, okay, or a natural aeration, so that you can say, which allows for air to penetrate deeper. And once the air starts penetrating deeper, that allows for the growth of various different microorganisms and microbacterium as well, which again, in a way, instigates the fertility of the soil to be maintained at a higher level. Okay, now, because of this characteristic of slow absorption and slow loss of moisture, the black soil retains moisture for a very long time, which helps the crops, especially the rain-fed crops, to sustain even during the dry season. What do we mean by rain-fed crops? These are basically those types of crops which are only dependent on rainfall. There you don't need to provide any additional irrigation. So this is what is completely dependent on rainfall, and no irrigation. So for example, when you talk about even cotton for that matter. Now, cotton is sown or planted immediately after the rainy season in general. And that amount of moisture is retained for a very long time, right? So that is why there you don't need to irrigate the fields quite frequently. It is retained for a longer period of time and a longer duration as well. Then we come across red and yellow soil. So red and yellow soil, where do you find? In the older plateau region of the peninsular area. So this is generally to be found in the older plateau area, older plateaus, plateau regions of peninsular India. So there, the igneous and the metamorphic rocks which have been created as a result of very old volcanic eruptions and very old lava spread, the presence of iron in them, that is what disintegrates and gives the specific coloration as red and yellow. We do know that iron provides a particular reddish coloration, so that is why you have the coloration of the soil as red. Okay, and why is it that the soil becomes yellow? So in the same plateau areas, few of the regions receive higher amount of rainfall. So when an area receives higher amount of rainfall in the presence of moisture, this iron gets converted into hydroxides and you have the presence of hydroxyl ions. So there, the hydroxyl ions, whenever they are formed, they have a yellowish coloration pattern, and that is why in those areas you find the presence of yellow soil in general. So that is the general characteristic. So you can think about it, the regional spread in the drier reaches of peninsular India, the drier reaches of all these plateaus. Various plateaus mean that you have Chota Nagpur Plateau, Bastar Plateau, then you have the region of Karnataka Plateau, also the Shillong Karbi Anglong Plateau. So all these older plateaus which are there, you'll find the presence of this. So in the drier regions, you'll find the presence of red soil. Now, out of these areas, wherever the rainfall amount and the rainfall quantity is even slightly greater, in those stretches and in those areas, you come across what? The formation of yellow soil. So, red soil develops on crystalline igneous rocks in areas of low rainfall, where in the eastern and the southern part of the Deccan Plateau, in the surrounding regions of the Deccan Plateau, and also along the Piedmont zone of the Western Ghat. Piedmont means immediately across the foothills, right? So there also you'll find the presence of the red soil. Yellow and red soil are also to be found in Odisha, Chhattisgarh, and the southern part of the Middle Ganga Plain. That is the region around Rajmahal Hills, the Chota Nagpur Plateau. That is where you will find the presence of red and yellow soil. So the soil develops a reddish color due to a wide diffusion of iron in crystalline igneous and metamorphic rocks. In crystalline, igneous, and metamorphic rocks, whereas the same develops a yellow color when it occurs in a hydrated form. That is, when you have the presence of moisture. Presence of moisture. Okay. Now, the fine-grained red and yellow soil are normally fertile, whereas the ones which have coarse grains, they will not be fertile, and that is the case with almost all soil types. It is poor in nitrogen, phosphorus, and also organic component. Why? Because again, it has been created as a result of disintegration of igneous and metamorphic rocks. So hence, it will be poor in organic component again. Okay. So that is the characteristic. So observe here this entire stretch. In this entire stretch now, the region of the black soil that has been in a way superimposed on the rest of the Peninsula Plateau, isn't it? That has happened, that eruption has happened the latest around 80-90 million years back. So other than that, in the other regions, you'll find the presence of this red and yellow soil to be in existence. You'll find the presence of red and yellow soil, okay, in this area as well. So that eases your understanding in a way, in the sense that we know that across the country's physiography, when we have studied the physiography, what are the major things that we have studied? Other than the mountainous areas, we have studied about the plain region. Now, plain region will have alluvial soil. We have studied the deserts. Deserts are very, very dry. So obviously the soil will also be sandy in nature. So arid soil conditions in the desert, here you will find the presence of arid soil, almost sandy in nature. Then the Peninsula Plateau is another major division that we studied. The Peninsula Plateau will have what? So the older ones, that is Chota Nagpur, Bastar Plateau, the region of Baghelkhand, the region of Karnataka Plateau, the Shillong and Karbi Anglong Plateau, all these ones, all these areas, you have the presence of red and yellow soil. In areas where you have the basaltic lava which spreads, that is where you have the black soil which is to be found, the black soil which is present. So that is basically the presence of various different soils. Okay, so obviously you can draw the rough map and you can always arrive at this conclusion on yourself. So other physiographic divisions, we also studied about the coastal plains, plain areas created by deposits. So what will be found? Alluvial soil. So across the country, you can have an idea about the type of soils. Now, in certain stretches, in certain areas where you have intermittent conditions of very heavy rainfall and followed by very dry conditions, there you have the formation and the presence of laterite soil. Laterite soil is significantly infertile, right? It is devoid of nutrients, and very infertile. Okay. Now, this is the laterite soil, the image that you see. Most of you, in many of the pockets, you would have observed this condition where the soil appears to be very hard, hard as a stone or a rock, right? It hardens. And when rainfall will occur, the same soil will start flowing like mud. But when you have dry conditions, it will be as hard as a rock. Most of us would have come across these kinds of soil types in some area or the other, isn't it? So laterite soil, they are found in certain pockets. It is not as if they have a significant zonation or a zone like the black soil or a zone like the red soil or a zone like the alluvial soil. They are found in certain pockets. Which pockets? The pockets where you have the intermittent wet spells followed by a long dry spell. So here we talk about alternate wet and dry season. That is where you find laterite soil. In fact, the name laterite in itself is derived from the Latin word later, which basically means brick. That is how hard it gets. And in fact, this laterite soil is also used for manufacturing bricks. Most of you would have come across this soil type sometime or the other, either in the rural areas, in the villages, etc. You would have come across the pockets of these laterite soil. So how is it that this laterite soil is created? So when you have a normal soil type, a presence of a kind of a normal soil type, let's suppose, yes, in Jharkhand you will find this. So let's suppose you have a normal soil type which has got various different nutrients present in it. Okay. Now, in situations of excessive amount of rainfall, if there is a significantly excessive amount of rainfall which occurs, what happens? high amount of rainfall leads to a kind of a draining of all this nutrient. So that high amount of rainfall basically dilutes the nutrients, and the nutrients, they settle down in the lower portion. That is why in this case, even if you observe the soil horizon, that is the various different layers of the soil, if ever you get an opportunity to observe that, you will observe that the coloration pattern also changes. So most of the nutrients, they accumulate in the lower regions. Okay, majority of the nutrients accumulate in the lower region. Accumulate in lower depths. Now, when I say, and listen to this carefully, when I say that all the nutrients are taken down, all the nutrients are basically brought down. So these nutrients, be it certain kinds of phosphates, potash, etc., I think it will be proper if we refer to them as different types of salts, right? Different types of salts which are present, which are brought down. Now, if in a particular area, if you remove all the salts, so that condition becomes acidic or basic. What do you think? Will it become acidic or basic as a consequence of that, once you drain down all of them? Perfect. It becomes acidic. Because all the salts, all the various alkalis that you have, everything is drained down. So that is why the resultant top layer, so the resultant top layer becomes acidic in nature. Okay? Resultant top layer becomes acidic in nature. Okay? So that is why this is a kind of soil which you will also find to be acidic in characteristic. And this property, where all the salts are brought down, all the various different salts, they are taken down, that is a property which is, or that is a phenomena which is referred to as leaching. So in this soil, we can also say that leaching happens. So this is what is leaching. Okay, so the property is also what is leaching. So here, observe this, that the coloration pattern in itself changes. All the salts, they are brought down to the lower levels, isn't it? Now here, basically, you have deep to very deep acidic in nature. The pH value is less than 6. It is poor in nitrogen, phosphate, and calcium. So this is mostly unfit for cultivation, mostly unfit for agriculture. However, in some parts of the country, after bringing in sufficient methods or measures to conserve the soil, proper aeration, addition of proper nutrients, especially in the region of Andhra Pradesh, Karnataka, Kerala, and Tamil Nadu, this soil is used for tea and coffee cultivation. So after adopting appropriate soil conservation techniques, it is used for tea and coffee, and also in certain areas it is used for growing tapioca and other kinds of crops. So red laterite soil in Tamil Nadu, Andhra Pradesh, and Kerala are more suitable for crops like cashew nuts, tapioca, and so on. Mostly you will find that this soil is used for commercial purposes. And when we say commercial purposes, for manufacturing of bricks. So they are widely cut as bricks for use in house construction and other construction activities as well. Okay, leaching is always bad. Leaching is never good. So leaching basically devoids the or makes the topsoil devoid of any kind of nutrient. Okay. Now, here laterite soil, by the way, you will find in small pockets almost spread across the country. Even in this area, that is the region which generally we depict in all different maps. We depict this region as the area where you have Aravalis, even in the region to the south of Delhi, around the region of Gurgaon. There also, what is the weather type that you have? Very intense rainfall, otherwise completely dry. So there also, due to lack of any other deposits, you have the creation of laterite soil in this area as well. Southern part of Bihar and also northern part of Jharkhand, even in portions of West Bengal, portions of Odisha, portions of Tamil Nadu, some portions across the Western Ghats as well, where you have very intense rainfall. So here also, so you have them spread across various different pockets. You don't have a well-defined zone which is in existence. In Rajasthan, you have in some pockets, but otherwise in the portion of Western Rajasthan, you have the sandy soil or the arid soil, which is present in the dry areas, right? Now, the arid soil, basically when we talk about it, so they range from red to brown in color. They are sandy in texture, saline in nature. In some area, the salt content is very high, and even common salt is extracted by the evaporation of standing water in certain areas. So due to dry climate, high temperature, evaporation is faster, and the soil completely lacks organic component and moisture overall. Why organic component is completely lacking? Because for disintegration or decomposition to happen, you do need the availability of warmer temperature as well as moisture. In an area where there is no moisture, the rate of decomposition will be absolutely negligible. So almost no decomposition will be taking place in this area. Nitrogen is also insufficient there. Okay. Then we have, so arid soil mostly found in the region of Rajasthan, and very good parts of Gujarat. So always use your natural logic, guys, for this case. Please don't follow the path followed by many of the candidates where they will write this down, the soil type, they will write the state on the other side, and they will start rectifying it. First of all, that is the general motion that they carry out. They cover it with their palm of the hand and they start rectifying it. Okay, Punjab, UP, then Bihar, West Bengal, Assam. These are the areas where you have alluvial soil. Okay, I forgot Odisha, I forgot Andhra Pradesh. So never do that. If you do that, there are chances that one or the two mistakes will happen. If you solve by logic, even if UPSC throws a random area in front of you, that logic will come to your rescue. Okay, so you won't be dependent on any particular list. And when you are not dependent on any particular list, chances are you will apply your mind, and that is when you will get it correct. Okay, right? Punjab, Yaramseti mostly consists of alluvial soil, mostly. However, that soil is becoming saline. But Punjab, again, understand, land of 5 rivers. In Punjab, if you move from one area to another, barely will you come across a stretch where, let's say, as you are traveling by road, you have not encountered a road or a river bridge, etc. So you have many streams as well. So that is why alluvial deposits. Okay? Right? Okay. Now we come across the forest and the mountain soil. So basically the mountainous areas, when we talk about the mountainous areas, so from the region of the bottom of the mountain, the foothills to the top, the conditions of temperature and rainfall, that changes. So as the conditions change, also the conditions of erosion and deposition also changes. Where is it that you will find more deposition? In the upper stretches or in the lower regions or the lower altitude of mountain? Always in the lower altitude. Very good. Always you will find in the lower altitude of the mountains more deposition will happen. So wherever deposits happen, The soil is fertile. Why? Because the deposits are consisted of or consisting of the minerals extracted from the various rocky surfaces, from the various different surfaces as the rivers move through. That is when you have the minerals which are extracted. So that is where it will always be significantly fertile. At the lower reaches, it will be very, very fertile. Okay, so they are formed in the forest areas. When we talk about where sufficient rainfall is available, that is a different soil type, very unique to the forest regions, where the vegetation in a way modifies the soil type. But when we talk about mountainous regions, they vary in structure and texture depending upon the altitude, depending upon where they are formed. So on the valley sides, you'll find that the soil is loamy and silty. Silt is brought by rivers. So deposit of rivers. Okay. Then in the upper slopes, coarse grain, because significant amount of erosion has not happened, the temperature is low, so weathering is slightly inhibited. Snowbound areas in the Himalayas, they experience denudation and are acidic with very low humus content, because all the organic, you will have lesser organic component at higher altitude, whereas in the lower valleys, that is where the soil is fertile. But in the upper stretches, the soil is infertile. So the soil in the lower reaches, they will be fertile, and the upper reaches, it is infertile. Silt is basically when we talk about silt, so the fine particles brought by the river in motion, that is what is silt in general. Okay. Why Punjab is so good at production? Production of what? When Uttar Pradesh has most alluvial soil. Okay. So you mean agricultural crops. That is because Punjab, Haryana, that is the region where traditionally and historically the electricity, rural electrification happened earliest. There, if you go to those regions, you talk to the older generation, the ones who carried out cultivation long time back, decades back. Even when they will recall their childhood days in the 50s and 60s, they will say that the electricity was not present 24 hours, right? But they will tell you that electricity was there. Whereas in the region of Uttar Pradesh, Bihar, West Bengal, you ask the older generation, many of them would have seen the erection of the electricity poles, or the installation of electricity poles in their immediate lifetime, in the recent past. So electrification was not there. Now electrification is very important. Why? In order to carry out irrigation, you need to extract water from tube wells. That has always been available. And also, immediately after independence, you had an increased focus in these areas to provide irrigational channels in those areas, and various canals were constructed. Whereas in the rest of the eastern part of the country, canal construction was something which the government in itself started paying attention in the 80s. By that point of time, the other regions had started their agricultural growth and were reveling in the agricultural growth. And once the government started paying attention in the 80s in the eastern part, by that point of time, the politicians in these areas, they also were capable enough to consume whatever resources was given, and eventually this region has been devoid for irrigation for a longer duration. So there are a load of institutional factors which basically allowed the higher production of agricultural products in the region of Punjab, Haryana, and the tracts of Western UP. You also had all the aspects of green revolution being implemented in those areas. Those areas were the labs for green revolution. So that is why they thrived. Okay. And if you get to read any of the books for after independence, that is post partition, that is, for example, one of the very good books is Freedom at Midnight. I don't know how many of you have read that. That is written by Larry King and Dominic Lapierre. So in that book, if you will study the plight of the people who came in from the other side, right, from the portion which now comprises of Pakistan's Punjab. So that was the portion where the Britishers had historically constructed a lot of canals. And that was the portion which was considered much more fertile. The portion that we have today in our part, that is what we consider as our state of Punjab, that basically was always considered to be poor in fertility. So people were allocated lands in that region that go there, we will provide you support, but that area was never used for agriculture in the pre-independence times, not significantly rich in agriculture. So that is why there was a lot of governmental support, institutional support to provide and build canals, to provide irrigation facilities, to provide infrastructure, rural roads were present. All these, they help in agricultural productivity. Okay, I hope that is clear. Then we have the saline soil. Saline soil is infertile. This is also what is referred to as Usar soil. Okay, it is highly infertile. Now here, when we talk about it, it contains a large portion of sodium, potassium, and magnesium, and thus they are infertile and do not support any vegetative growth. How is it that the soil becomes saline? So basically, you can understand this even at your own level. If it at your backyard, you can experiment this and you can understand how the soil becomes saline. So mostly it happens as a result of capillary action. Capillary action of water. So where in the presence of narrow channels, the water tends to rise up. So what happens here? Understand. So when you have basically a soil type, let's say, and you have significant high amount of water which is there as a result of rainfall, or mostly in the case of India, that excess amount of water is created due to over irrigation. So excessive water logging and why does that excessive water logging happen? Due to over irrigation. Because in many parts, especially for agricultural purposes, electricity is very cheap, if not free. So what is the general kind of a behavior that you will observe, a general kind of a trend that you will observe, that during the evenings, people will switch on their tube wells. Late at night, they will switch on the tube wells and they will go to sleep. And then again, they will put an alarm at around 4 a.m. in the morning or 4:30 in the morning. And that is when they will switch off the tube wells. In that entire duration through the night, the land is watered continuously. And you have significant amount of standing water which happens. Because what is our conception? The conception is, and the general understanding, that is where we are failing the agriculture in a way, that the general conception is soil needs water because the plants need water. So rather than giving it separately, individually, why not give it excess water or too much of water so that next day at least my soil is happy? Because we start treating them as individuals. That, okay, this person needs food, I will give them the entire basket of food and then I will be free for the entire day. That is how we treat the soil as well. We switch on the tube well and the pumps that keeps on pumping water throughout the night. The water stagnates and then next morning we switch it off. Now the areas that we are talking about, that is the region of Punjab, Western UP, Haryana. What is the condition in terms of rainfall in those areas? The amount of rainfall is high or low? What do you think? The amount of rainfall, is it high or low? Very low. And that in those areas, is the amount of rainfall high? No. very high degree of evaporation. Whenever you have evaporation, then basically, will the salts also evaporate along with them, or will the salts be left behind? We have seen it continuously. Whenever evaporation happens, the salt is left behind. So that is when all the salts, they get left behind. Let's use this color. So that is where the water evaporates, leaving a layer of salt after it. So the salts are left on the surface. Now, these salts, when they are left on the surface, then what happens? Basically, they form a very hard kind of a crustal layer, okay? Because these salts, they will also harden. So along with the soil, they will form a very hard crustal layer of sorts. So then, do you think it will allow the penetration of air, penetration of water to the lower reaches? No. So it makes the soil almost impermeable. And that is when the soil slowly and steadily starts losing its fertility. It becomes infertile and it has got absolutely no ability to support any kind of vegetation. That is the condition that majority of the areas in the region of Punjab, Haryana, and Western UP, they are facing now. Now, this is something that you can, as I told you, this is something that you can even practice at your own house. Any kind of soil that you have in your backyard or in any of the flowering pots that you have, where the plants are not growing, do one thing. Pour in half a glass of water. You would have observed that that water is very quickly absorbed. Very quickly, it is absorbed by the soil. Now, pour in 1 jug of water. Even that, let's say, is absorbed. Pour in more water. After a point of time, you will start observing that on top of water, there is a development of a kind of a white structure, whitish foam kind of a structure or whitish film develops on top of the soil. That is nothing but the salts which are pushed up as the water oversaturates that layer of the soil. And as that water will evaporate, you will observe white deposits on top of that soil. Let it dry. After it has dried completely, look at the texture of the soil. It will be very hard, right? Because the salt, that would have formed a thick crustal layer on top. That is where the soil starts becoming infertile. And this is observed in majority of the green revolution areas of the country, where traditionally you have the growth of the various food crops happening because of the application of the fertilizers, the nutrients, etc. Now you have to understand, whenever you apply fertilizers, you have to mix it with water. It is not as if you take a pill of urea and you throw it and the plant will digest it on its own. You have to dissolve it in water. So the more fertilizers that you apply, more water is needed. More water that you apply, you expose the soil to saline conditions. So it is a kind of a cycle from which these areas are unable to extract themselves. And that is why the soil is losing its fertility. So in order to allow the regaining of the fertility, what needs to be done? You have basically the conditions where you add certain parts which improves the texture of the soil, which improves the water retention capacity of the soil. And for that, you add gypsum powder. So in arid and semi-arid regions where you generally experience very little amount of rainfall, and in waterlogged and swampy areas, that is where you find them. So areas of intensive cultivation with excessive use of irrigation, especially in areas of green revolution, that is where the fertile soil are becoming saline, and the farmers are advised to add gypsum. Why? To increase the soil texture. That is water retention and air retention. Yes, Vaibhav, these are man-made disasters. Air retention capacity increases. Okay? Shruti, Shruti, do one thing, write a mail. We'll get back to you. Okay, I hope you have my mail ID. So any of the questions that you have, which you are hesitant to ask in the class, for various different reasons that happens, feel free to write a mail to me. We'll get back. Don't worry. Okay. And please understand, there is no issue which is large or which is small. All of us, while preparing, we face various different types of obstacles and drawbacks. It is how we overcome them. That is what defines us. It is not the amount of information that we come here with. It is the amount of information that we are able to extract out of it. So don't worry. There is nothing to be ashamed of. Gypsum adds to the hardness? No. So it is not as if you add rocks of gypsum. Okay, Shivani, in this case, what do? You basically pulverize that gypsum. So the small powdery formation. So when you mix it with soil, it is not something that it will become very rich in gypsum, but the trace quantities, they will always have a greater availability and retention of water. Okay? Absolutely, yes, Vaishnav. Any kind of issue for preparation. See, our purpose here is to help you clear the examination. Any kind of issue that you face, whether you are unable to understand what to prepare, whether you are unable to understand what to focus, which areas to focus into, how to distribute the time and the resources, etc. Any issues that you face, always you have my mail ID. You can ask from the SMEs. They will provide you the mail ID. Even the mentors will provide you my mail ID. My mail ID is available. Write to me. Feel free to get in touch. I will get back to you, provided. So in that, have a bit of a leeway. It should not be that you have written me a mail tonight and tomorrow morning you send me a kind of an urgent reminder. Why have you not replied till now? How dare you? Not like that. Give me a couple of days. I will clear the mail as well. Okay? So that is basically the characteristic of these various different types of soil. Now, SETI, northeastern state soil, especially around Arunachal Pradesh. So again, the region SETI around Arunachal Pradesh, what do you have? You have the mountainous areas. So in the lower stretches in the valley region, there will be deposits. In the upper stretches, very dry conditions. So dry conditions, you will have coarse grains, infertile soil. So that will be present across the entirety of the stretches. Okay? And right? Waterlogged and swampy area means where you have standing water, where you have stagnant water. That is waterlogged. So excessive irrigation. Even some areas of Tarai belt. Tarai is generally very fertile, but that is naturally draining itself. So let's say in a region of Tarai belt, you have stopped that natural drainage by construction of a building in some area. So water is unable to drain itself with ease over a period of time. So water tends to stagnate. And that, if there is lack of rainfall, that will lead to saline conditions. Okay? Mangrove areas will have, so that is, again, that is a kind of, when we talk about mangrove areas, there also you have saline conditions, but that salinity is mostly because of aridity, that is lack of moisture. That is where you have those conditions. Yes, Shamil. But in Sundarbans, mostly you have fresh deposits that happen. So wherever fresh deposits happen, you have the presence of alluvial soil and alluvial soil which is present. Okay? Yes. Pranay, that is correct. And Seni, I'm unable to look at your question, my dear friend. What is your question? What happens if we remove the top layer, Shravani? If we remove the top layer, then the lower layers, they will have coarser grains and they are infertile. So the ability to support the crop types completely goes away. Saline soil can lead to flood in conditions of heavy rainfall like flood in Jaisalmer. So saline soil will never lead to flood. How can a saline soil lead to flood? Think about it. Can a saline soil cause flood? No. But after a flood, yes, there can be creation of a saline soil. Yes, that can happen. Devansh, because how gypsum increases air retention capacity, basically gypsum particles you add. So let me write here so that you don't get confused. So small particles. Very small particles. So just like in the case of black soil, we saw that whenever you have small particles, the ability to retain water is very high, ability to retain air is also high. Something similar happens in this case as well. Yes, Bharti, that is true. Swati, again, when you remove the topsoil layer, when you remove the layer of the topsoil, so the bottom layer has a larger grain size. It will not have any organic component, so it will be infertile soil, no ability to support any growth. Reason for soil formation is deposition only? No. Weathering and disintegration of rocks is the major reason. And paddy fields are continuously watered, so can we consider it as less fertile? So paddy fields, where as we continuously water it, so there again you have a kind of misutilization of water which is carried out. So paddy again is cultivated in various different methods. The traditional method is that of a flood irrigation, where you allow the water to be stagnant for some amount of time and then you transplant or translocate the small saplings and allow the paddy to grow. That is one of the methodologies, one of the characteristics. Now, whenever that happens, whenever you have a lot of standing water, when that evaporates, that creates saline conditions on the ground. So ideally, when the saline conditions won't be created, when those areas receive continuous rainfall. So that is why it is said that paddy should always be grown in those areas which receive almost around more than 120 centimeter of rainfall throughout the year. Only in those areas. So the regions of Punjab, Haryana, Western UP, they are absolutely unsuitable, not suitable for growth of paddy. Those are the areas where you should not grow paddy because the amount of rainfall is very less. But what do? We overcompensate it with irrigation. And when you do that, you are turning the soil saline. Layers of soil, Priyanka, we covered it yesterday, the various different horizons. Or look at the fourth slide. There we have covered it, that the top horizon, the bottom, and at the bottom you have unweathered parent rock. Okay. Yes, Shivani, that is correct. Right? Okay. Now, then we come to the portion of soil erosion. So soil erosion basically is what? Erosion is the process of removal. So when you have any kind of natural factors in the sense natural agents of nature, that is, you have the strong movement of water, heavy rainfall, very strong wind movement, any of those characteristics, if they are able to remove the top layer of the soil, that is what is referred to as soil erosion. Now, we have seen the factors which create the or lead to the formation of the soil. We have looked at the factors. Now, the factors leading to the formation of the soil basically give us an idea that how much time does it take to form a soil, a thin layer of soil. It can take hundreds, thousands, sometimes even millions of years to form a very thin layer of soil, because the rock will get disintegrated, that will get broken down into multiple smaller pieces. So a reiteration of this process eventually ends up creating a layer of soil having very thin granules, very thin grains, isn't it? So here, as this process continues and as this process is persistent enough, that is when you have the creation of that topsoil. Now, in cases where there is nothing which can hold the topsoil in its own place, and the topsoil is, let's say, left absolutely barren, and this is something you would have observed. If not, yeah, it is high time in your life that you can observe this. So basically, let's suppose this is the soil, topsoil. Now you would have observed this, that when there is a large drop of water which falls here, there is a small kind of a splash which is created. You would have observed this. There's a kind of a splash created, right, when the water drops, and you have tiny, very tiny grains of soil. They are separated from that region. That is what is splash erosion. So if there is nothing holding the soil, any amount of external force will have the wherewithal to remove the top layer of soil. And that is what we refer to as soil erosion. Soil erosion is considered to be very harmful, because after all, it is the top layer of the soil which can support all kind of vegetation. It can support the different types of microflora, microfauna as well. So the top layer has got all the fertility, and if the top layer is removed, again it will take hundreds of years for the bottom layer to get disintegrated into again that fine layer, right? Now, why does this erosion happen? Erosion can happen due to two major factors. One is absolute lack of vegetation. Lack of vegetation. And then the other is high speed of agent of nature. Which agent of nature? Wind, running water, rain, etc. Okay, so that is basically what leads to the removal of the top layer. If there is nothing holding the top layer, how will the top layer stick itself there? The top layer will be removed easily. That is a major problem. That is why you would have observed that in majority of the areas, wherever you have the slightest amount of slope, if there is nothing holding the soil together, availability of rainfall invariably will lead to the drainage of entire soil away. And that means this area will eventually be devoid of any kind of vegetation whatsoever. Okay. Now, another example I will give you, something that you would have experienced on a real life basis. Many of the times we don't understand that this is another form of removal of soil, but understand how important it is to hold the topsoil together. When you move on a road, generally you would have heard that Government of India for the past few years, that is for the past 3 to 4 years, they have made a norm to plant large trees on the sides of the roads, national highways. So that is where a lot of money is being spent to plant those large trees. Now, what do you think is the purpose behind it? Obviously, one of the purpose is to increase the tree cover. One of the purpose is to provide the shade, reduce the noise and the light pollution which happens on these roads. That is the aesthetic purpose. Now, those of you who are coming from the branch of civil engineering, etc., you would be knowing about the fact that the prime role or the prime utility of planting trees on the sides of the roads is to hold the soil in its place. That is why you would have observed that in areas where there is no tree, even if there is a highway which has been constructed, a good road, a standard road which has been constructed, over a period of time, you will observe that the road starts developing a kind of a bump. That in certain areas, the level goes down, it comes up, then again goes down. And as the traffic moves ahead and heavy trucks keep on plying, so even those upraised areas, they are then removed. And that is when you have the complete breakdown of the road. Now, why is it that the road tends to develop these kinds of bumps? That is because the bottom layer of soil, that is moving away from there. So that is why if there is nothing holding the topsoil will be removed. And that is something we cannot afford. So soil erosion is a major issue. Now you have various different types of soil erosion depending upon how this erosion is carried out. So we start with the first type, that is the sheet erosion. Sheet erosion. Okay. So sheet erosion. Generally, when we say sheet, sheet basically refers to something which is very thin, right? So in case an area is devoid of rainfall and there's a slightest amount of gradient, here observe how with the flow of water, the top layer ever so slightly is being carried away. And not only in one part, in various different parts, it is being carried away. So the fine and the fertile top layer of the soil is something which is carried away following a high amount of rainfall. Whenever you have very high rainfall, that is when you tend to observe this phenomena. That is when you experience this phenomena, isn't it? So sheet erosion takes place on level lands after a heavy shower, and the soil removal is not even easily noticeable. But then, what will happen if the rainfall comes again? So if this region receives rainfall again without any proper conservation measures being implemented, don't you think that the water will utilize the existing channel for flow? So from all areas, the water will come here and they will start draining from this region only, right? So when the water starts using this channel, it will get deeper ever so slightly. Again, the next bout of rainfall, the next round of rainfall, the same process is repeated. Again, this will start getting used. This will be used significantly. So this repeated usage, when it happens, eventually that sheet erosion can lead to development of small channels, right? Those small channels, like what are referred to as the small streams, or what are referred to as rills. Yes, Pratyaksh. Also nalas in certain case as they are referred to. So they will develop small rills and channels through which water will flow. Now again, if still you have not taken any step to conserve it, these rills will further deepen. And when they will further deepen, what will they develop? They will develop a gully, right? They will develop a gully. Observe this. Observe this particular a kind of a deeper extraction which has been carried out, and that is the development of a gully. This is what is a gully erosion. So gully erosion is common across the steep slopes because obviously water will have a channel and they deepen with rainfall. They will eventually end up cutting the land, fragmenting the land due to or with the help of multiple channels. They will fragment the land into multiple parts. Obviously, a land which is fragmented, that will never be utilized, that cannot be utilized for commercial purposes. So such kind of a land which is fragmented with many different gullies, that kind of a land is, or that kind of a topography is also referred to as badland topography. Badland topography. Again, a humble suggestion for travel. So most of the times I give you the suggestion that do travel, do explore. Here again, if ever you get an opportunity to travel, let's say by train from Delhi to Mumbai or Delhi to anywhere to the south, that is through MP, Gujarat, or anywhere in the southern part, the railways will carry you through the portion of northern Madhya Pradesh. That is the Chambal Basin, right? Now there, as you cross across the region or move across the region around Guna, Gwalior, Bamor, Morena, those districts particularly, you will observe on the sides of your railway tracks that these are devoid of vegetation. And these are fragmented with multiple small gullies. Over many of them, you have the bridges now which have been constructed. That is the amount of erosion which has been carried out. So that is basically a badland topography. Now, if the rainfall continues, now here, this rainfall, as and when it continues, it will continue to deepen these gullies, right? And then you will observe the development of a ravine or a ravine in general. So that is when you have the gully erosion leading to ravine erosion. Now, ravines are almost like a miniature river stream where you will have a very swift flow when there is significant amount of rainfall. But when there is no rainfall, it will be absolutely dry and barren, right? So that is where the land keeps on getting degraded. So region with large number of deep gullies or ravines is called badland topography. Ravines are widespread, especially in the Chambal Basin, particularly in the districts of Morena, Bamor, Gwalior. You'll find a lot of them. Okay. So, Nitesh, don't worry. Sometime time will come when you will have the time to travel, or when UPSC will make you travel to Delhi. So make sure that you witness it at that point of time. Okay. How can we differentiate gully erosion and river-made erosion? Gully erosion, Priyank, river-made erosion. See, the riverine erosion is generally observed only across the river banks. Gully erosion can exist far away from the river banks as well. It is not as if gully erosion will be in the region of the floodplains, immediate floodplains itself. It can be far away as well. Okay. Then we have the stream bank erosion. Stream bank. That is, here stream represents a river. So this is an erosion carried out across the river bank. So when does this happen? When across the river bank, you don't have the presence of any kind of supporting vegetation, any kind of tree for support. So as the flow in the water tends to increase, that water has got an erosional capacity. So from the sides, the rivers will continue to pluck small amount. Observe this area. Observe this region. It is as if somebody has scooped out this particular area. Otherwise, normally it would have appeared like this. But observe that in these areas, it appears as if somebody has scooped it out. So when you don't have enough vegetation on the side, and vegetation does not mean that I have my paddy fields there. No. Deeper root systems which can hold things in position. So unless and until you don't have that in place, the rivers during the rainy season, when they have got enough power, they can take away the part of the stream bank. Particularly those of you living in the regions of northern part of Uttar Pradesh, particularly in eastern part of Uttar Pradesh, also in portions of northern Bihar, portions of Assam, portions of West Bengal, and nowadays across the region of Godavari, the lower stretches of Godavari, you would observe that during the rainy season, when the spate of the river increases, so sometimes you have large tracts which are taken by the river, including many houses altogether, right? So large tracts are taken along with the river flow. So that is where stream erosion is washing away from the banks of a stream or a kind of a river. That is where you need to have a kind of a vegetative cover. When you have the vegetation or a growth of dense vegetation, let's say, even across one area, if it is eroded, the other vegetation which is present on the sides, they will protect it. So that is why the more deforestation we carry out, more erosion is resulted as a process. Then you have wind erosion. Wind erosion, when you have an absolute lack of vegetation, so the wind speed also increases. When you don't have any barriers or boundaries, the wind speed significantly increases. And that is when the wind is able to carry the finer particles along with it. Again, in the regions of Haryana, nowadays, because of how we have converted the soil, even in regions of Punjab, at one point of time, you could never even imagine this to be a case in Punjab. But now, thankfully, to our efforts of how sustained farming we have carried out, even Punjab is experiencing this. Western UP, Haryana, Rajasthan, Madhya Pradesh, Gujarat, in all these areas, we are experiencing large tracts of or large impacts created by wind erosion. Now, we have looked at erosion and we have looked at why erosion happens. So, if you have to apply your logical common sense, I know it is hard, but if you have to apply your logical common sense, that how is it that you can stop this erosion from happening? So, obviously, the steps will be very simple. Anything which will lower the speed of these agents of nature along with the vegetation. Now, any of these two factors, if you facilitate, you can basically prevent erosion to happen, isn't it? So that is what constitutes the conservation measures. When we say conservation measures of soil, we are basically bringing those practices to prevent the soil erosion from happening anymore. Okay? But before that, we take a look at soil degradation. So degradation is what? Reduction in quality, right? So when the soil quality reduces, either by the soil becoming infertile or by the topsoil getting removed. When the degradation happens, either by the topsoil getting removed or the soil turning infertile, that is soil degradation. Decline in soil fertility. So either due to erosion or decline in fertility. Now we know the causes for erosion. We do know. What about the causes for decline in fertility? Why is it that we experience decline in fertility? Think about it and we'll discuss it after the break. So we take a break now and we take a break for 15 minutes. Okay? Think about it. What can lead to decrease in soil quality? Let's be back after 15 minutes. A confirmation for the audio, please, guys. If the audio is available. Thank you. Niharika, if you have missed the sessions, you can either attend the another batch which is going to start on the weekend in April itself, or you can also have a look at the recorded sessions. Now the videos are also recorded, so that also will be available to you. So you can choose any of those. And the reasons for the decline in fertility. So deforestation, excessive pesticides, excessive irrigation, intense leaching, monocropping. Very good, Nitesh. Bharti, inadequate fertilizer use, large demand for food due to expanding population. Very good. Intensification of agriculture without maintenance of fertility. Very good. Pratyaksh, extra pesticides, water logging. Shamil, alkalinization of soil. Shreya, contamination of soil with toxic pollutants. Good. Lack of crop diversity. Very good point. Very good. So most of you have been able to point it out. So let us find out what are those factors which lead to decline in fertility, all the portions that you have pointed out. So yes, the degradation can be carried out either due to erosion, or it can happen because of the fact of over irrigation, excessive fertilizer usage, then after that, lack of crop diversification. Erosion we have already pointed out. Abhishek, erosion is a different factor that leads to degradation. This is fertility that we are talking about. Lack of crop diversification. Good point, Vijay. You have solid waste dumping. Then we don't allow the soil, or we don't give soil enough time to recharge its fertility. So inadequate time. For regaining fertility. Okay. So basically, all of these eventually, in a way, when we say decline in fertility, so in a way, it leads to the reduction in the biological activities which the soil normally generates. I hope that we are aware of one basic fact, that it is always said that 1 tablespoonful of soil many of the times is able to contain as much amount of biodiversity as you find in case of a grassland as well, in the sense that it will have so many different types of microbes, so many different types of worms, so they are very important to maintain the fertility. Now if we over irrigate it, that is stagnant water, standing water, so that will cause leaching as well, right? That can lead to salinization of the soil as well. The soil turns saline. Or in a case or in a situation when we say excessive fertilizer usage, excessive fertilizers, they make the soil absolutely infertile. For example, when we talk about the application of fertilizers, we do know that ideally what is prescribed is that NPK should be applied in the ratio of 4:2:1. But obviously, that is not followed. In certain areas around Punjab, you will be surprised to know that this ratio is skewed in the sense of almost around 36:8:1. Think about it. that for 1 unit of potash, in certain areas we are adding 36 units of urea or nitrates. Obviously, when you apply so much of fertilizer, immediately all the various different microbes which are naturally present, they will immediately die, isn't it? So that is where there is a significant decline in the soil health, immediate decline in the soil health. The situation is almost very similar in Haryana as well. In Haryana, and this was a detailed study carried out by Down to Earth magazine. That is where the detailed report came out, where in Haryana, in certain areas, it was 27.5 is to 6 is to 1. So, over application of fertilizers, that is one of the major causes for turning the soil infertile. But that is not the only cause. We do know that we have a consistent growing season where in majority of the parts of the country, especially the northern plains, you have rice, which is sown, then it is harvested, then wheat is sown, then again rice, again wheat, again rice, again wheat. So this rice-wheat cycle which carries on, it extracts the nutrient out of the soil. It makes the soil infertile and unproductive. So in order to compensate for that, what do the farmers do? They pour in more fertilizers. More fertilizers mean more water you need to put in to digest those fertilizers. And then again, the soil becomes saline. So these are the leading causes. In fact, UPSC has also been asking this question time and time again for the past decade and a half. If you find and if you analyze few of the questions, you will find the persistent presence of these questions both in the general studies as well as in the portion of geography optional. That UPSC asks this question, what are the damaging impacts of the rice-wheat cycle? How to break this rice-wheat cycle? What can be the alternative? Alternative can be that you grow different types of crops. For example, after one season, you start growing pulses in that area. Now, pulses or other peas, grams, etc., they will naturally enrich the soil fertility. And when the soil fertility is naturally enriched, automatically the soil becomes much better for the next growing season as well. So there has to be crop diversification, there has to be a crop rotational practice which has to be carried out. A result of this is being observed in the areas of Western UP, Haryana, Punjab, more primarily so in those areas, where you will find that now the productivity of the soil has reduced, and it has reduced very drastically. Now, here, what do you think will happen? Unless and until you provide that excess amount of fertilizers, there is nothing which will grow. So can we not say that the natural growing ability or the natural ability of the soil to support plant growth, that will reduce naturally, and under normal conditions, the soil will not be able to support vegetation at all? We can say that. So imagine if we have harvested a crop and the soil is left naturally, then there won't be any growth of any kind of plants, natural plants. You won't find to be growing in that kind of a chemical soil which is left. So there is a lack of plant presence. What can it lead to? If there is a lack of plant presence under normal condition, what will it lead to? Very good. It will lead to erosion. Significant amount of erosion. The topsoil will be eroded. Once the topsoil is eroded, the bottom soil will never be able to support vegetation. So that area which has been degraded slowly and steadily converts into a desert. So that is where soil degradation is becoming one of the leading factors which is leading to desertification. Desertification is a term which has been in prevalence for a few decades now. In fact, in the portion of environment and ecology, I'm sure you will study about this, that you had the aspect or the understanding of the fact of desertification was that the existent desert areas, the areas which are present or which are desertified areas, now There, due to wind erosion, the sand in the existing desert would be carried out and would be deposited in the vicinity, in the neighboring areas. Now, in the neighboring areas, if the sand is deposited, will it lead to the growth of plants in that area? Absolutely not. The plants cannot grow. So that is the expansion of the deserts, right? So earlier that was understood to be the aspect of desertification, that is the peripheral, absolutely yes, Monica, expansion of an existing desert. Okay? Peripheral expansion of an existing desert, that was understood to be the main ideology or the main factor of increase in the desert land. But then lately, we have also come across the fact that is when you had the convention, United Nations Convention to Combat Desertification, when you had the Conference of Parties for that, which was held in India in September 2020. At that point of time, land or the soil degradation was considered to be another major issue, which is leading to a normal land getting converted into desertified area. So a degraded soil degradation. Yes, Sumit. Soil degradation eventually leads to a lack of natural vegetation. And when there is a significant lack of natural vegetation, that exposes the soil to what? To erosion. And that eventually creates desertified areas. So if I ask you a question, let's suppose if I frame a question that soil degradation can lead to desertification, will you have the ability to write 150-word answer out of it? That soil degradation leads to desertification. Will you have the ability to write an answer out of it? Perfect. So in case such a question is asked, what do you write? You write what leads to that soil degradation and why it will lead to desertification, why there will be no natural vegetation which will be found in that area, in an area where the soil is degraded. We can get that, right? So this was a question which UPSC had asked in the mains examination as well. If you have the ability to write it, you will always have the ability to write it in the exam hall as well under that pressure. Okay, so that is all that you need to know about the aspect of the issues of the soil. Now, when we talk about conservation of soil conservation. So conservation means what? Only the volume of the soil to be retained or also the quality of the soil to be retained? Conservation also means conservation of quality, always. So that is why soil conservation basically is a methodology to maintain soil fertility, prevent soil erosion and exhaustion, and improve the degraded conditions of the soil to make it less degraded. So all the aspects which lead to the degradation of soil, be it erosion, be it decline in fertility, if we are able to understand what leads to erosion and what leads to decline in fertility, obviously, we can also talk about what can be done to prevent that. So basically, you have factors like contour bunding. Contour. What contour is again an English term, right? Contour means sinuous lines, a kind of a lineation, a linear pattern, right? So contour bunding, contour terracing will come to it. Regulated forestry, controlled grazing so that overgrazing does not lead to erosion, cover cropping, so that in between different cropping seasons, you plant something, but don't leave the topsoil to be exposed. Never leave the topsoil exposed. In fact, if you talk with the various different environmentalists and agriculturalists, they will always tell you that exposure of soil is the worst thing that you can do. Exposure of soil to the outside environment is the worst thing that can be done to the soil. It is like if you have an open wound and you expose it, what happens? Immediately there will be infection, right? And that portion will be gone almost, right? Similarly, in the case of soil, when you expose it to the outside environment, you allow it to be exposed to the outside environment, it will get heated, prolonged heating, prolonged cooling will happen. So the soil will tend to lose its fertility one day at a time. And that is when the soil will be absolutely degraded. So you can have afforestation programs, regulated forestry, mixed farming, crop rotation, all of this can be carried out. What is contour terracing? So what you observe here, observe, it would have been a hill slope. Ideally, if it would have rained in this area, everything could have been drained away. But rather than that, what we have done is we have made various different terraces. Isn't it? Terraces across a line. So what happens because of this? The flow of water tends to reduce. The velocity of water tends to reduce. And as the velocity of water reduces, its ability to erode will also reduce, isn't it? So that is something which can be done. What is contour bunding? What is bunds? Bunds are a kind of an artificial barrier of sorts that you create. So imagine when we talk about contour bunding, so imagine an area which has got a kind of a slope, right? Ideally, if it would rain here, let's make the slope a bit more normal, less steep. Let's say like this. So if it rains, it will drain away the topsoil because the water will gain momentum as it starts to move. So there you make certain bunds. Imagine if on the in the front view, if this area appears like this, so you make bunds here. Bunds. These are your bunds. Right? So in this case, what happens? If there is water which is present, that water will never be able to gain velocity. Even if it gains velocity, it will be stopped here. Right? For a brief duration that the water is stopped there, some part of that water will percolate. It will recharge the groundwater also. And then again, if it manages to overflow, it will flow. You will have another bund that will again stop the flow. So anything which stops the flow, which regulates the flow, prevents soil erosion, can be a method of soil conservation. Even for that matter, think about it. When I said expansion of desert in the peripheral areas, which is the causative factor which is leading to that expansion? It is the wind erosion. Wind erosion is carrying the sediments, right? These are, by the way, these are your bunds, artificial barriers. Artificial barriers. Okay. So basically, wind erosion is carrying the sand from the desert to the vicinity areas. If, let's suppose, across that desert, I construct a kind of a plantation, in the sense that you have the green trees which serve as a kind of a natural barrier. In that case, the wind velocity will reduce. So the wind will not be able to carry that sand into the non-deserted areas. So that can also be a method of to combat desertification, isn't it? That is why across Africa, you will come across the Green Wall program, where to the south of Sahara Desert, as the Sahara Desert is expanding southwards, the program has been initiated by the African Union, where they have initiated a plan to construct a natural barrier of green plants and green trees across the vicinity of the desert so that the desert doesn't expand. So these are the methodologies which can be brought into practice in order to conserve the erosion and the degradation of soil. Okay, understand this, and that shall be sufficient both for your prelims as well as for your mains exam. Okay, now we come to the portion of agriculture. Vaishna, but didn't we study that open soil areas can help to mitigate the effect of urban heat islands? So open soil areas, by that we meant those areas where the soil is naturally present rather than being covered with pavements, construction and houses. So soil can also be naturally present under these trees or in between the trees. There also the soil will carry out the mitigation of heat. Okay. Yes, Vaibhav, that is the solution, agroforestry. And bunding will help to reduce the velocity, yes, and also the recharge of groundwater, Vishal. Apart from afforestation, what can be the steps to prevent desertification? You can carry out cover cropping in the surrounding areas. Also, you can reduce the level of degradation because degradation is also leading to desertification, isn't it? So that can also be done. Windbreaks, as they are referred to, very good. Okay. Yes, Devansh. Okay. Now, we come to, does rate of decomposition influence the soil fertility? Avni, yes. If the rate of decomposition is very fast, that means the soil will be devoid of organic nutrients. If the rate of decomposition is slow, that is, as is observed in the temperate regions of the world, that soil will be always enriched with organic components. Okay? Right. Is deserts need compulsory or not? Seti, yes. Deserts are also essential because they end up supporting a different kind of biodiversity altogether. So deserts, their requirement is also important. Okay. Now, Pratyaksh, China is taking huge steps in this, yes. But as is the case with China, recent fact finding has also indicated that one of those images that China had circulated, where, and it was very unique, no other country will have the guts to pull off something like this. So they had circulated an image on social media through their news channels, that is, you have the CCTN and so on, the South Asian News, etc. So they had indicated that you had several hills and hillocks, which earlier indicated a barren look. Now they appeared completely green. And the world celebrated that as a kind of a conservation measure of China. It was recently revealed that what it was basically China on a large scale. They had made a kind of a green mat, an artificial mat, and they had hooked it on to those hills to give it a greenish appearance. So it is like, as if, imagine that your house on the inside is, the plaster is broken, everything is in bad condition. From the outside, you give it a makeover so that it appears in the a very good condition. So that was something which was revealed in the case of China last year, which caused a lot of embarrassment. But then past couple of years, China has learned to withstand these embarrassments now. For them, it doesn't concern them anymore. Having said that, there are success stories to be taken in the case of southern part of China around Yunnan province, where you have the presence of these hills, and excessive rainfall would create a lot of erosion and landslides in that region. But a conversion into a kind of a terrace farming has made that region as one of the rice bowls of China. So they end up producing large quantities of rice, and that has increased the agricultural productivity. But that has happened in some pockets, and now the environmentalists across the world, when they take a look at China, they take everything in with a pinch of salt, because you never know. China could have covered the entire thing in green cover or a green kind of a carpet, and we are reveling and we are thinking that why can't we do it, right? But because we are thinking it in a different manner. So that is something or some feat that only China can pull off. Only China can spend money in these kind of cover-up stories. Okay. Now, here we come to agriculture. Very, very important for the point of view of your examination. Why? Because agriculture is one of the mainstays of our Indian economy, and we have been facing various issues in agriculture as well, and due to which the overall farm income is reducing. Farmers have been in distress. The activities or the incidents of farm suicides, overall they have reduced over the past decade. But any farmer who is forced to commit suicide because of crop failure or due to any other issues, that is a blot on our face, that is a blot on the image of the country. So that is why it is relevant for examination, and UPSC has been asking questions from here. So what is the portion important for your prelims? So for your prelims, you get questions for, just like the same pattern in the case of forests also, in the case of soil also, in the case of rivers also, and same will be observed in the case of minerals and industries also. That is types of crops, and then regional spread, conditions required, okay, newer techniques or newer methods of irrigation, etc. Newer methodologies for irrigation, improvement of productivity, all of that comes under the portion of current affairs. This is something you will be exposed to in the portion of current affairs. This is one of the reasons why I suggest to you to study the magazine of Down to Earth, and I will always recommend to you that take one weekend, any of those weekend. You can finish the magazine of Yojana, Kurukshetra, and Down to Earth in any of those Saturdays or Sundays, whenever you have a comparatively relaxed time. So always refer to that. That keeps you updated, and that also broadens your horizon. So Down to Earth will help you in significant ways to understand this. Then for the mains examination, here you get questions generally asked in GS paper 3 mostly. So here, issues in agriculture, then after that, green revolution, limitations, and benefits. Even though nowadays benefits are not asked, because the benefits for green revolution, they have been reducing. Then after that, methodologies, to increase the farm income. Okay, so these are the questions that you generally tend to find appearing in the mains examination. Okay. Now, all this we will cover in the PPT itself. What I would suggest to you that look at the PPTs, restrict yourself to the PPTs as much as revision is possible, and keep looking at the portion of current affairs. That is where newer techniques and technologies will come into the picture. Okay. You can revise this portion from the tablet lectures as well. There also, you can revise this particular portion of economic geography. Now, agriculture. Agriculture is not new to us. Agriculture has been prevalent for a very long period of time. In fact, ever since mankind discovered agriculture, ever since mankind started practicing agriculture, that is when humans, they started leading a sedentary lifestyle, right? The hunting and gathering, that stopped. We started living in the same place. We started developing settlements. That is where the existence of the concept of settlements also came into the picture. So agriculture has been a mainstay in our region or in our part of the world. Not now, not for the past 100 years or not for the past 1,000 years, for the past 5,000 years and more. In fact, the Harappan civilization, the Indus Valley civilization, when you study about it, next time when you open up the book, observe that you had certain crop types which were grown even during at that point of time. So that is where agriculture has always been relevant. Various different civilizations that you come across, the ones which have prospered, various different kingdoms, historically, how have they prospered? With the help of agriculture. Even in India, during the Delhi Sultanate, you suddenly had the rise of the Khiljis. The Khiljis became very powerful. Why? Because the agricultural produce in the Doab region could increase incrementally. The Chola Empire became so mighty. Where did they get that money from? Eventually, to become powerful, you need money. Where did they get that money? By the growth of crops like rice and cotton in the region of the Coromandel coast. When we talk about the Vijayanagar and the Bahmani kingdoms, they also became powerful. Why? You had the Tungabhadra Doab. Now, if you take a look at the Byzantine outside India, Byzantine Empire in the present-day region of Turkey. So Byzantine Empire also became rich and powerful. Why? Because they developed modern irrigational methods. At that point of time, it was very modern, where they could carry the river water for many kilometers, tens and hundreds of kilometers inland through the aqueducts, and they could provide that irrigation, significantly improving the agricultural output. The Magadhan Empire, the Magad kings, be it the Nandas or the Mauryas, they were again very powerful. Why? Agricultural output. So agriculture has been the mainstay till the Britishers came over. That is when the agricultural standard in our country that suffered a very severe degradation and disintegration. It was a kind of a systemic dismantling of our traditional methods of agriculture. And India, a land which was always considered to be self-sufficient for our own people, India as a land started experiencing famines where you had a lack of crop output, due to which people would die out of hunger, starvation. In fact, again, in modern history, you will study that you had great famines, devastating famines through the 1700s, 1800s, and as late as 1940s, which claimed millions of lives. Overall, if you consider the British policy of agriculture, you will find out that due to the mismanagement, we have lost more people due to starvation in these years as compared to what Hitler did in Germany. We have lost many more people. That is how criminal it was. And India, which became independent, had a very poor condition in terms of its economy. We did not have enough food to feed all the citizens. We were dependent on food imports, let alone imports. We did not even have money to pay for those imports. We were dependent on grants, that Western powers, they would grant us food aid. You had the United States basically was one of the larger donors. And United States, under its own legislation, that is, its legislation was Public Law number 480, which was also, as an acronym, it is referred to as PL 480. Under that program, United States would give food grains like wheat to third world nations, underdeveloped nations like India, Pakistan, and so on. And we would be dependent on it. We would be waiting for that. It is because of this dependence on food where India, in many of the cases, we were in a way forced to toe the United States foreign policy or the United States view of the global order because we were dependent for food. It would make national headlines. All the newspapers would bring it on the front page that another ship carrying wheat grains has arrived on the Indian ports. And now we would get food. That was the condition after independence. It was in the 1960s when India decided to come out of this rut. And India wanted to come out of this. So that is when, in the 1960s, early part of 1961, you had an Integrated Agricultural Development Program, IADP, which was initiated. Now, while that did not bring much of a success, but that paved the way for bringing of newer technologies and newer methodologies in the form of Green Revolution. And Green Revolution was implemented in certain areas. At that point of time, you can understand that how hesitant the government of India was. Many of the bureaucrats, they were not ready to basically implement the policies of Green Revolution. They were not ready to provide the governmental or the institutional support required for irrigational facilities, etc. It was a doyen, a pioneer in the name of Dr. M.S. Swaminathan, right? The agricultural genius that we had. He started implementing this in his own backyard. And that is when he showed the output to the bureaucrats. And that is when it was implemented with the help of the government support in the region of Punjab, Haryana, western part of Uttar Pradesh. Canals were dug, electricity was supplied, rural roads were built, markets were constructed. And within a couple of decades, those regions became food grains and food bowls of India. A country which lost lakhs of people in the 1940s due to starvation, within 50 years, that became one of the largest producers of those food grains. Fast forward it to today. We export more than close to around $50 billion worth of agricultural goods. We are either the largest or the second largest producer of almost all the food grains that you can think of. A country which did not have enough milk, which is a very traditional, a very cultural source of nutrition that we have. From north to south, from east to west, milk forms a part of a basic diet. We did not have enough milk for all the citizens. We have transformed ourselves to be amongst the largest milk producers of the world. So the transformation has been unique. If nothing, it has been exponential and momentous. And during that transformation, we have now become one of the largest producers of food grains, where in an year, we produce more than 300 million tons of food grains. In 1 year, we produce more than 300 million tons of fruits and vegetables. Not only do we have enough for us, when there is a food deficiency anywhere in the world, they look forward to Indian help. When the Russian-Ukraine crisis broke out, and the world was reeling under pressure because they did not have enough wheat, which is the country which stepped in? It was India. And thankfully so, because we have suffered so significantly because we were dependent on the kindness shown by the other countries. We don't carry out any of this discrimination. Thankfully so, we realize that even though we have come a long way, we still have miles to go before we gain a kind of a truly satisfactory result. Now, yes, in that journey, there have been few errors which have also occurred. And that is a part and parcel of any natural journey that you traverse through. There have been errors in the aspect that we lost the basic essence of agriculture that we had been following for thousands of years. For thousands of years, we basically had relied upon what? Natural methods. That was the specialty of this land. If you talk to the elder generations, especially in the region of Punjab, Haryana, or even across the eastern coastal plain, all of them will tell you the same thing, that around 50, 60 years back, the land was so fertile, you drop a seed, it would grow. Now, the land is such, unless and until you pour in bags of fertilizers, the land will not give you any return. So yes, there have been various issues due to which the farm income has reduced. As the reduction in farm income has happened, there has been increased sense of dissatisfaction which has been created at the same time. And that has led to various different social and political issues along the way as well. That is why we need to study agriculture. That is why we need to understand agriculture so that we improve it. And there have been instances where the bureaucrats, that is the IAS officers, they have managed to change the entire face of a particular region's agricultural growth. The best case in point is the region of Vidarbha, in the region of, or in the eastern part of Maharashtra. If you open up the newspapers around 10-15 years back, more than that, if you open up, the entire newspaper of that region would be filled with the news of farm suicides, crop failures, etc. Thankfully, you had the bureaucrats in place who understood that why is it that the crops are failing in that region? Because we are growing those kinds of crops which ideally should not be grown in dry areas. In areas which are not receiving rainfall, we are growing sugarcane and rice. Why? Because the expectation is that the clouds or the gods might be kind to us this time and they would bring rainfall, but that doesn't happen. So that is when newer methods of irrigation were brought in, different types of crops were introduced, and now that region is moving towards agricultural growth, slowly but steadily so. Also, this has brought about a newer economic prosperity in that area along the way. So that is why agriculture is important and relevant to be studied. Okay? Now, here we start with agriculture, and you have to understand that even today, more than 50% of the population across our country, we are directly or indirectly dependent on agriculture. More than 50%. In certain data pointers, you will find 55, certain 53, certain 51, 52, etc. Whenever you find such data pointers, rather than banging your head in the wall that I don't know what to rely, this is why I will fail in the exam, do one thing, always write approximately or around. So around 50%, more than 50%. Okay, even if you write that much, UPSC will be satisfied. Okay, so more than 50% of the population is involved in agriculture. The gross value addition with agriculture, due to agriculture, is closing or nearing to $300 billion, the size of the economy of our neighboring western neighbor, Pakistan, which is still dependent on the imports of the grains, on the grant of the grains. Both of us, that is Pakistan and India, both of us were dependent on the grants around 60 years back. Look at where India has come. Now, exports from agricultural activities are to the tune of around $50 billion. India is expected to have produced close to around 316 million tons of food grains in the year 2021-2022. So that is the growth that we have done. It is nothing short of momentous. It deserves a celebration. It deserves an applause. Regardless of whatever anyone might say, this has been an incredible journey. But at the same time, it will be absolutely ignorant of us to think that things are perfect. Things are not perfect. Things need improvement. The farmers, they are in distress in many parts of the country. Few of the farmers, they are prospering. They are turning more and more prosperous. Whereas there is another area where the farmers are in a way forced to leave their land, work as landless laborers in other people's farmlands. So that is the condition which we need to improve. Okay? So here in this particular unit, what is it that we will study? Different types of cropping patterns, different types of cropping seasons, major crops, the conditions required, irrigation facilities, green revolution, organic farming, and a methodology of organic farming, that is zero budget natural farming. That is again something that we will study about. Okay? Is India still an agriculture country? No. In case if you think about it from an economy point of view, no. Because here, and that also highlights the ineffectiveness of agriculture and inefficiency in agriculture. Because if you think about it, more than 50% of the population, when they are involved in agriculture, they contribute only around 15% to the economy, right? So if more than 50% contribute only 15% to the economy, there is something wrong, right? So we don't consider India to be an agrarian economy in terms of the economic purposes, but in terms of the population and demographic dimension, yes, majority of the population is still involved in agriculture. Shivam, due to high rainfall last year, wheat crops were destroyed. No. Shivam, wheat crops were destroyed because of different reasons. Because of heat waves, right? Incessant heat waves. Because of high amount of rainfall, rice was, or the area under rice cultivation, that was impacted. Okay? And the rest of your question is that why we exported wheat? Because we still have a lot of surplus. After banning the export of wheat, still we have significant amount of buffer stock. So there is no shortage. And please understand, in the time of the pandemic, no other country has managed to distribute food grains, free food grains, to that large amount of population as India has done. We have managed to distribute free food grains to close to around 80 crore people in the time of the pandemic. That is nothing sort of a momentous task. Think about it. No other country has managed to do that. And we are still continuing that. So that is where we still have enough buffer stocks. And yes, the rainfall, the thunderstorm which has occurred in the last week of March and in the middle of the month of March, that can reduce the wheat output a slight bit. But let's see. Let's keep our fingers crossed. This is the harvesting season of wheat that we are in. Let's see after the harvest what we get to. Okay? Right? And yes. So we come to the various different types of agriculture practiced in different parts of the world and different parts of the country as well. So here we have primitive subsistence farming, major types, intensive subsistence farming, and commercial farming. Now here, intensive means you make maximum utilization in terms of labor force, etc. Subsistence means the kind of farming for self-sustenance. That is, you grow enough to feed yourself and your family, and you save some amount to be grown as seeds next year. That is it. There is no profit motive, there is no selling motive in this. Primitive means very rudimentary tools and technologies, lack of technology, So traditional method. Traditional methods. Okay. Intensive subsistence. Again, intense subsistence means for self-sustenance, very little surplus, very little will be sold in the market. This mostly relies on fertility of the land. Relies on fertility of land. Is there still a disturbance of sound? Are you able to hear me perfectly well, or is there a disturbance in sound today? Kindly let me know, guys. Is the sound perfect? Okay. So, intensive subsistence farming, that basically ends up relying upon the fertility of the land. If the land is fertile, that is where people carry out the farming. So, where is it that you get fertile land? Mostly across the rivers, the sides of the rivers, that is the floodplains of the rivers, mostly floodplains of the rivers. Of rivers. Okay. Then here, intensive means all the people of your members of your family, they will be directly or indirectly lending their hand, they will be lending their support, and they would be lending the kind of labor force required for growth of food or the growth of food grains. This also lacks technology. No technological advancements are used. Very simple form of agriculture. Commercial farming for profit purposes. Profit motives. Unlike the other two, here you have large farmlands. In the other two, you have small farmlands. Here you have large farmlands. Okay. Now, profit motive. So you grow one type of crop in large volume. You have processing plants within your farmland itself, and you sell it off. That is not for your self-consumption, that is for selling purposes. So you will use modern technology, you will use modern methodologies, the efficiency will also be more, you will require large amount of labor force also, isn't it? So these are your features. Let us take a look at them. When we talk about primitive subsistence farming, so it is practiced in small piece of land using very basic and rudimentary tools and techniques, very basic. And food produced is chiefly for self-consumption. Okay. Now, mostly the modus operandi is used is of a shifting type of agriculture. What is modus operandi? The method of operation. So mostly the modus operandi is shifting type of agriculture. What is this shifting type of agriculture? That is basically, let's suppose here you have a particular region which is forested, and this is basically practiced in those areas which do not have a kind of a natural availability of transportation, etc. That is not present. It is not well connected with infrastructure. So isolated areas, the hilly areas, the tribal regions, the forested regions, in those areas where you don't have the adequate facilities. So there, people independently, they carry it out. So what do? Suppose they want to carry out cultivation in this area. So what they do is, first of all, they will cut down the forests in these areas. They will slash down the forests. Now, after slashing down the forests, whatever residue will be left, they will burn it off. So slash and then burn, right? So after that slash and burn, you basically leave the soil for a few days. allow the ash, etc. to mix. You wait for the rainfall to come. When the rainfall arrives, then you plant the crops and you grow the crops on top of that. You grow the crops on top of that. So that is basically once you have cleared the land. Now, after a couple of seasons, this particular land will lose its fertility, because obviously these areas, the isolated areas, you don't have the enough amount of inputs to recharge the soil fertility, etc. So after a couple of years, after a couple of seasons, the soil will lose its fertility. When the soil does manage to lose its fertility, then what is done? In that case, you simply move on to another area. You leave this soil and you clear another area, and you slash and burn other area. So you are shifting the farmland based upon the fertility of the soil, based upon the requirement of cultivation. You are shifting from one place to another. That is why shifting type of cultivation. Now, in this case, technology used is very less. What do you think will be the size of the farmland? Size of the farmland will be greater or smaller? What do you think? Shruti, yes, it leads to deforestation. Size of the farmland will be very small, significantly smaller. What do you think about the agricultural output? Agricultural output will be higher or smaller, lesser or higher? Agricultural output will also be less. So, in the case of very less agricultural output, people in this region, they are forced to carry out other activities like beekeeping, hunting, gathering, etc. to ensure enough amount of revenue or enough amount of food supply as well. So that is the characteristic of shifting type of agriculture. So it is also referred to as jhum cultivation in some parts, slash and burn agriculture. It is migratory in nature, where you migrate your farmland, your area of cultivation from one region to another. Land is cleared with traditional tools and cultivated for a few years. As the fertility declines, land is abandoned in favor for another freshly cleared patch. Cereals and tubers are chiefly grown. Hunting, gathering, fishing, and bird rearing, that is also done as a method of side income or as a method to support the dietary needs as well. Latin America, tropical regions of Africa, South and Southeast Asia, wherever you have densely forested areas, hilly tracts, in those isolated regions, this kind of cultivation is chiefly practiced. Then when we come to intensive subsistence farming, observed in river valleys and delta plains in South and Southeast Asia. Here you have very small farms due to high population density, right? We have seen that population density will be very high in the case of alluvial soil regions because the farm is productive enough. So you have dominance of food crops, especially rice, high intensity of land use. Each and every parcel is used. It is labor intensive, where you have family members, they themselves, they lend their hand. So obviously you have more people depending on the farmland. If more people are dependent on the same farmland, what will happen to the level of farm income? Will the farm income go up or will the farm income reduce? What do you think will happen in this case? Very good. The farm income reduces. So you have very low farm income. Majority of the farmers in our country, they carry out this. Traditional methods like crop rotation, mixed cropping, etc. is carried out to maintain soil fertility. Low levels of commercialization due to very small surplus. In this case, farm income is also less. Size of the land is also very less. Land is very less. Farm income is also low. Is also very low. Okay. Then commercial farming, purely for profit, right? So single crop to be grown on large land holding, large estates, land estates as they are referred to. It is highly commercial. Now, in that large land area, if you have to carry out the cultivation, the number of labor force required will also be very high. And if that labor is expensive, nobody can afford that, isn't it? You need cheap labor force who is ready to work at a very cheap price. So labor intensive, capital intensive, you need to invest a lot of money in that also. That is when it will give you heavy returns. You need a processing infrastructure. Generally in such farmlands, you have the processing infrastructure as well. So tropical equatorial areas in Asia, Africa, there in certain areas it is carried out. In India, commercial farming is carried out in the region of Punjab, Haryana, Western UP, in those areas which have thrived under Green Revolution. There you will find, typically if you enter into any of the villages in Haryana or Punjab, you'll find this kind of a common feature. All of you belonging from those areas, you will attest to it, that you have a very large farmland in general. In between that, the farmer would have constructed a very nice house, a kind of a palatial house, where you will have a large tube well also, where you will have tractors, etc. And because of the prosperity which has come in, nowadays you will start observing few of the luxury cars also parked simultaneously in that farmland. So that is where commercial farming can give you very good dividends and very good returns, right? Now, then commercial livestock and grain farming. So this is where, along with farming or along with growing of the food crops, you also cater to caring of the animals along with it. So you cater to animals also, animal husbandry as it is referred to. So it is a kind of a mixed farming. Mixed farming is crops plus animal husbandry. So, humid temperate areas like Northwest Europe, Eastern North America, parts of the erstwhile or the older Soviet Union, that is the region of the areas around the present day region of Ukraine, also the portions of Russia, also the western and central portion of Russia, Australia, New Zealand, Tasmania. These are the areas. Equal emphasis is laid on crop cultivation as well as on animal husbandry. So that is what is mixed farming, where both of them are carried out. Crops such as wheat, barley, oats, rye, fodder, all of them are taken care of. Intensive use of land is made. High level of modernization and commercialization. High capital expenditure on farm machinery, building, agrochemicals, processing infrastructure, all of that is done. And crop rotation and intercropping is also done to diversify the type of output that you can generate out of your farmland. So these are your types of agricultural practices which are observed across the globe in general. Okay? Now we come to the kind of cropping pattern. Cropping pattern basically ends up depicting something very simple, and that is the arrangement or the type of cultivation that you carry out in your farmland. Okay, so in order to understand this, before reading all this text portion, in order to understand this, when we say cropping pattern, so pattern, simple English translation, pattern in which you carry out your cropping. So it is broadly of two types: monocropping and multicropping. Monocropping and multicropping. Now what is it? Monocropping. Mono means what? Single. So only one crop you grow in your farmland throughout the year. For the rest of the part of the year, you leave the land fallow. So only one kind of crop is grown. Kind of crop is grown. For the rest of the year, The land is left barren and fallow. Multi-cropping, that is where you grow multiple crops. Multiple crops are grown in an year. Okay? Now, multiple crops can be grown in various different methodologies. It can be intercropping, it can be, in a way, sequence cropping, it can be mixed cropping. Mixed cropping is different from mixed farming. Okay? So it is of multiple types. Let us take a look at the definitions now. I hope you understand the basic difference between mono and multi-cropping. So basically, here, monocropping. So it refers to growing of only one crop on a piece of land year after year. And once that crop is harvested, after that, you can leave the land fallow or barren and you grow another kind of crop, or after another season, you can grow it. But the same crop in 1 year. Then multiple cropping. Growing 2 or more crops on the same piece of land in 1 calendar year, that is referred to as multiple cropping. Okay? So for example, in 1 piece of land, let's say I grow only rice and then I leave it barren for the next season. Next monsoon again I will grow only rice. That is monocropping. In another piece of farmland, let's say I have grown here rice. After I have harvested it, I have grown mustard. After I have harvested it, I have then grown, let's say, watermelon or cucumber. After I have harvested it, that is what completes 1 agricultural season. So in this, I have grown multiple crops in the same year, right? So that is multi-cropping. Multi-cropping is of various types. That is intercropping, it is mixed cropping, and also sequence cropping. Intercropping. Intercropping is what? Intercropping is when you have, let's say, a farmland. Right? Now, here, growing of 2 or more crops simultaneously on the same piece of land with a definite row pattern. For example, let's suppose I have grown here wheat in a row. I have grown wheat. Here again, wheat. Here again, wheat. And in between them, let's suppose I have grown chilies or tomatoes. Here and here. So in a mixed row pattern, I have grown various different crops in a kind of a fixed row pattern. It is not randomly grown. It is a fixed row pattern. So this is what? This is intercropping. Intercropping. Right? Then you have mixed cropping, where you don't follow a particular row pattern, you grow it randomly. So basically here in some portion I have grown rice, simultaneously some portion onion is also growing. In some other portion I have grown millets as well. In some portion chilies are also there. In the leftover portion I am growing potatoes as well. So there is no fixed pattern. Everything is mixed, intermingled. That is what is mixed cropping. Okay? In the case of intercropping, you have different kind of basic delineation which is there. Then sequence cropping. In the case of sequence cropping, what happens? Let's suppose I have a farmland. Let's suppose I have a farmland, which is generally observed. Now in this, During the monsoon season, I grow here rice, isn't it? Let's suppose I grow here rice. Then after that, I harvest it in October. Then I plant wheat. I harvest it in April. Then after a month in June, again I grow rice. So I'm growing it in a kind of a sequence. Multiple crops I'm growing in a year, but in a sequential manner. So sequence cropping is growing of two or more crops in a sequence on the same piece of land in a farming year. Okay, so these are your various cropping patterns, right? Mixed is when two or more crops simultaneously without any definite row pattern. Okay, monocropping can lead to soil erosion. Yes, Himanshi, very good. Okay. Yes, Prashant, take any other example. I hope you understand the larger picture of what intercropping refers to. You can take any example here. You can take the example of any vegetable. You can take the example of any food grain. So it is not necessary that food grain necessarily needs to be grown. You can have the growth of vegetables as well. Okay. Every country in the world witnesses seasons. Yes, most of the countries in the world, they will experience seasons. Sequence is subpart of multi-cropping. Yes, multi-cropping has got various subparts A, B, and C. These are your subparts of multi-cropping. Okay, all of these are your subcategorization. That is why I had drawn this here. These are your subparts or the subtypes. You have intercropping, sequence cropping, mixed cropping as subparts of multiple cropping. Okay. Then we come across the cropping seasons of the country. Now, cropping seasons mean that under certain conditions of temperature, rainfall characteristic, only certain kinds of crops can grow. It is not as if any kind of crop can grow in any kind of condition. So you have certain types of crops which can grow here. So we have three major cropping seasons. Two of them are major. In fact, one is the minor one. First is the Rabi season. Rabi is also referred to as the winter crops. These are your winter crops. These Kharif, they are also referred to as monsoon crops. And these are your summer crops. So when we say Rabi, Rabi, basically it is sown or planted when? In the month of November, late part of October itself, but mostly November, December, sometimes even in January. And it is harvested in the month of March, April. Okay. Then when we say Kharif, it is sown in the month of when? Yes, June, July, harvested in the month of September, October. Example of Rabi. Rabi example, wheat, mustard, few of the pulses. They can always be taken as the example. Kharif. Kharif, you have the examples as rice, cotton, right? And millets, they can also be considered as Kharif, right? Then you have Zaid, that is sown, that has got a very short growing period. So Zaid, that is sown when? It is sown in the month of April. Okay, harvested when? Last week of May or generally June. Okay, example, watermelon, cucumber, muskmelon, etc. A Vaibhav, jowar can be grown both as rabi as well as kharif. Similarly is the case with maize as well. They can also be grown as rabi as well as kharif. Okay, right? So this is basically your major cropping seasons. The important crops, if you look at it, barley, wheat, peas, mustards, all of these are examples of your rabi crops. Rabi crops. Right? These benefit from your winter rains that are caused because of western disturbance. However, in the initial days, they require that amount of rainfall brought by western disturbance. It is only in the later phase when they experience that rainfall, it becomes disastrous for them. Right? Then you have paddy, maize, jowar, cotton, tur, groundnut, soybean, all of these are your, generally, these are your kharif crops. Okay, all of these are your kharif crops. Yes, Sayadri, these are your kharif crops. Then watermelon, muskmelon, cucumber, these are your zaid crops. Also, okay, so these are your typical zaid crops. So one by one, we'll take up the major crops that we have. We'll try to understand the conditions where they are grown and the regions where they are grown. So we start with rice. Rice basically is the tropical crop and generally grown in the tropics, and that too in the high rainy areas of the tropics. Overall, they require a higher temperature of around 25 degrees Celsius and above, even 22 degrees Celsius and above, high humidity with the average annual rainfall of 100 centimeter. That is the minimum rainfall of 100 centimeter. It is not as if 90 centimeter will also do. No. Generally, rice requires a rainfall of around 150 centimeter and the minimum should be 100. Right? That is the minimal requirement. So obviously, those areas where you have that rice to be grown, those areas where this rice is grown, typically across the world you will notice that the regions which receive very high rainfall, be it across the hilly areas, be it across the coastal regions, or be it across the equatorial belt, that is where rice is typically grown because they have high amount of rainfall availability. Now, in India, development of irrigation in regions of less rainfall makes it prevalent to be grown in even those areas. That is why we are growing rice in the region of Punjab, Haryana, Western UP as well. Overall, if you observe it, these are the areas which don't receive adequate amount of rainfall. They don't receive 100 centimeter of rainfall. And how do we compensate that? We compensate that by extracting groundwater. And that groundwater is eventually evaporated. Right? And then we say that we are producing rice. Imagine, ideally, is this sustainable over the long run? Absolutely not. In all these areas, the groundwater has been depleted to such an extent that you have basically, in these areas, the groundwater is now contaminated with arsenic, fluoride. In the cases of, in the region of Punjab, groundwater has now got traces of uranium as well. Imagine the impact on our health. So that is where we keep on producing rice even in those areas. Ideally, it should be produced in the regions which have adequate amount of rainfall, coastal areas, eastern parts of the country. So in states like Assam, West Bengal and Odisha, you have 3 crops of rice which are grown. Os, Aman, Boro. So Os, Aman, Boro, what are these? These are different varieties. One is sown, Os for example, is sown in the month of June, July, harvested in the month of September. Aman, for that matter, is sown in the month of July and August, harvested in the month of October, maybe November. Boro, it is sown in the month of November, December. It is harvested in the month of April or March. right? So for example, across the Coromandel coastline, Boro is grown because that is when they receive rainfall. So that is where in certain areas in the same year, all these three varieties can be grown because you have adequate amount of rainfall which is present. Okay. Now, here basically India is the second largest producer of rice after China. In 2021, around 128 million tons of rice was significantly produced. These are your classification as major and minor areas of rice production, where you would observe these are your major areas. And one trick that you should always remember to understand which are the major and the minor areas, these are your major areas, where typically the amount of rainfall is so high that it supports the cultivation of rice. One of the tricks that you can always put into practice is look at the dietary habits. Look at the staple food that is consumed. Staple food means that during the day, what you consume mostly during the lunch and the dinner. Wherever you find that rice is an important component locally, not an individual, that as an individual I will never consume rice, that never constitutes a local dietary habit. So the local dietary habit, if you look at it, that will always be based on the kind of a food crop which grows there naturally. So observe that in the eastern states and also across the southern states, the coastal regions, rice grows naturally. You'll find that to be in the normal dietary habit. Whereas the minor growing areas, where you grow rice because of other conditions which are provided. So in these areas, you'll find that rice is not a staple food. Wheat is a staple food in those areas. Across the world, you can put this into practice. Whatever dietary habits that you observe across the world. For example, in the region of Mediterranean, you will find that along the continental cuisine, in fact, you have separate books which are written on the history of food as well. So basically, if you look at the continental cuisine, you will observe that in the Mediterranean region, mostly fruits are consumed because that grows there under Mediterranean climate very easily. In the region of Central Asia, in the region of north to the north of the Indian subcontinent, you will find the large consumption of bread and bread items. Wheat grows naturally. Okay, so by that you can always get an idea about what grows naturally in a region. Okay, now this rice which is produced, it is in the minor producing areas. This is basically not a kind of major, or it is not naturally to be grown in that area. It is only grown because we provide excessive amount of irrigation there. It is unsustainable. Imagine if you are exporting the rice which is produced from this region, produced in the region of Punjab, Haryana, Western UP. You are not only exporting rice, you are also exporting your groundwater. The traditional method of irrigation or cultivation of rice, 1 kg of rice, to produce that, you end up using close to around 5 kiloliters of water. So, in a way, you are exporting your natural resource as well. Why do people grow that? Because if you grow that, you get a minimum support price. So that is always a kind of an attraction. That is why we need to break that rice wheat cycle, which is very persistent in all these areas. We need to break that in order to make agriculture more sustainable. Okay? Now, then we come to wheat. Wheat is a rabi crop. Wheat is typically grown in areas which have lesser rainfall. 70 centimeter adequate rainfall. Even lesser than that. Wheat will never grow in an area which receives more than 100 centimeter of rainfall. That is why the 100 centimeter rainfall line, think about it. We will not go into the consideration of what is ISO, Hayat, etc. But the 100 centimeter rainfall line, that is considered to be a differentiating factor between the areas which naturally grow wheat and the areas which naturally produce rice. Typically, wheat grows in cooler conditions. That is why across Central Asia, Asian region, that is across the region of Eurasia, that is around Russia, Ukraine, those are the largest producers of wheat. Right? So these are your natural producers. So this Rabi crop requires a cool growing season and a bright sunshine at the time of ripening. If you have rainfall at the time of harvesting, at the time of ripening, wheat crop is destroyed. It requires rainfall at the time of sowing. That is why the western disturbances, when they bring rains during the month of December, it is helpful for wheat. But then during the month of March, when these thunderstorms and rainfall happen, that destroys the standing wheat crop. When you go to the market to sell wheat, any of you who have been involved in the process, basically you would observe that the moisture quantity of wheat is measured. If the amount of moisture in the wheat grain, if the amount of moisture is less than 20%, your grain is very nice. You get the adequate price. If the moisture quantity is above 20%, you get reduced price. Okay, so that is why unseasonal rains brought by western disturbance can be a destroyer of the wheat crop. However, last year, India lost a lot of wheat crop due to the persistent heat waves. So that is why India's wheat crop production was reduced in 2022 because of persistent heat waves. Now, India's rice crop or rice growing area was reduced in 2022 because of excessive rainfall which happened during the month of June and July rather, later part of July, which in a way prevented the sowing of the rice as well. So these climatic conditions, now that you have studied the portion of Indian climate, now that you know the basis of agriculture, utilize this in order to understand that how and when a particular factor is leading to an agricultural growth or an agricultural loss. Now, there is no reason why you should not be able to foretell, looking at the weather conditions, that whether it is good for the farming or bad for farming. Okay? So it requires 50 to 75 centimeter of annual rainfall evenly distributed over the growing season. Two important wheat growing zones, Ganga Satluj plains in the northwest and the black soil region of the Deccan. Okay, major wheat producing states Punjab, Haryana, Uttar Pradesh, Bihar, Rajasthan, and some parts of Madhya Pradesh as well. So these are your, now observe the same fundamental if you apply, these are your major wheat growing areas. Major wheat growing areas. Observe the culinary habits or the diet, the staple diet in these areas. You will observe traditionally bread or what chapatis, they are consumed on a daily basis. So that is because wheat is produced, right? These are your minor growing areas. Again, India is the second largest producer after China. Production in 2020 and 21 was again close to 111 million tons. Okay. Shruti, why you not give the data of 2022, 2023? My dear friend, that is not how the data works. The 2022 and 23, wheat is still being harvested as we speak, right? So this data will be generated 2024, and that also will be a kind of an estimate. And it is only in the later part of 2024, the later part, that is in the month of October, November and December, where you will get an idea about the wheat produced during 2022 and 2023. You will get that data in the last part of 2024. See, as of now, a farmer who is present in Punjab who is cutting the wheat, how will he know what is the total weight that he has generated? And let alone the weight that he has generated, how will we get to know the consolidated data for the entire country? So I hope that you are aware that this is a lag in agriculture. So next year economic survey that you will study, that will give you a final foolproof data of 2021, 2022. Next year economic survey. This year's economic survey gives you a data of 2020 and 2021 and an estimate of 21, 22. Next year, you will get a detailed report of 2021 and 22. So there is a lag. It is not as if I don't want to give you the latest data. You do one thing, even if you find it out on the government website, you will find it is an estimated data, right? Even for the matter of exports, you will not get the data that what is the total agricultural wheat export in this year or last year. You will get for 2021 right now. Okay. I hope you understand this. Okay. And trust me, even if you put in this data, first of all, nobody is going to ask you the data that, okay, tell me how much wheat is produced this year. That question never comes in prelims. Even if you write this data in the mains examination, more than sufficient. If you manage to recollect it at the time of the examination, you are already above 90% of the candidates. So before the examination, entering into the, all those of you, I'm sure one person has asked this, but many person will have that doubt that what is this old data is giving. We are in the month of April 2023 and this person is talking before the Amrit Kal period. So it is not as if we have a reluctance to provide you with the data. That is how the agricultural data follows. Okay, I hope that is clear to all of you. Okay. Yes, UPSC never asks you about production. Have you ever seen? See, because production, because if UPSC starts asking production, imagine the good, or imagine the joy of the candidates that they will get. Because if UPSC asks you what is the total production, A 111, B 12, 3 13, somebody will say you have not counted my village. My village produced 5 tons more. Somebody will say you have not counted my area. I know my area has produced 5 million tons more. UPSC never asks you these questions. Okay, it will always ask you a kind of an analytical question. So UPSC knows where the candidates can play, and that is where UPSC also likes to play. Okay. And yes, rightly pointed out, Umesh, this is the exam you are applying for. You are not going to be data collectors or data managers. That is where UPSC conducts lower grade examination to appoint people who are going to give you that data. And you as a district collector or the district magistrate in a particular place, or the secretary, if you become one, your job will be to analyze the data, to look through it, observe the pattern, and find a solution. You are never supposed to do calculation. Otherwise, UPSC would have put calculation as it puts in SSC exams. It doesn't put that in this, because understand that job you are applying for, that job has got a prestige. Okay. Now, okay. So just this millets will do, and then we'll end the session, guys. So millets, basically, they are also referred to as a poor man's farm, poor man's friend, or a poor man's crop, because this is one of those crops which doesn't require much care or much attention. Soil type is poor, no worries. Climate is changing, no worries. Rainfall is less, no worries. There is not enough irrigation, no worries. Millets can grow in almost all types of conditions, right? So in India, you have major types of millets which are grown are jowar, bajra, and ragi. All of you appearing for the exams this year, millets are important for this year. And even those of you appearing for next year, millets are going to be important. Why? Because this is the year we are celebrating as International Year of Millets. International Year of Millets. Right. So that is why millets, first of all, they don't have that much of a tantrum like rice or wheat that give me these conditions, only then I will grow, otherwise I won't grow. They are very sturdy, they are very relaxed, they can grow under any conditions. And secondly, they will give you huge amount of nutrition and nourishment as well. So they will provide you with micronutrients, fibers, iron, calcium, which is very much required. In a country like India, where we are facing malnourishment and malnutrition, not due to lack of food, but the type of food that we are consuming, this can be a godsend. This can be very beneficial. That is why millets, they should be preferred. In many portions, millets are, in many parts of the country, millets are basically promoted to be grown. Okay, so jowar, bajra and ragi, these are the three types of millets that we have. Jowar, third most important crop in terms of after wheat and rice, rain-fed crop, totally dependent on rainfall, no irrigation, okay, is required. So major jowar producing states, Maharashtra, Karnataka, Andhra Pradesh, Tamil Nadu, Madhya Pradesh, also parts of Telangana, parts of Gujarat, they have also been producing a lot of jowar. Okay, it is the southern states which have been gaining a lead into this, and that is something which states like Punjab and Haryana need to learn from it. If you observe the states of Telangana, states of Karnataka, states of Tamil Nadu, despite the regions receiving lesser amount of rainfall, they have incredibly simply changed the types of crops and they are growing millets at an incredible pace. Not only the farmers, the government, the administration, they are providing the support, they are providing the post-processing facilities as well, so that the production can increase, so that it is more sellable in the market as well. Okay. Then you have bajra, which is pearl millet. So jowar is also what is referred to as sorghum. When we say jowar, it is also what is referred to as sorghum. Then when we talk about bajra, so bajra, particularly known as pearl millet, is a coarse grain crop and considered to be poor man's staple nourishment, suitable to cultivate in dry lands. Bajra is one of those which is typically grown in Rajasthan, Haryana, naturally indigenously grown in Haryana, Uttar Pradesh, Gujarat. Very low rainfall, 40 to 60 centimeter, temperature variation 20 to 30 degrees Celsius, it can grow. Now, this can serve multiple purposes. It can help as valuable animal fodder as well. So at the same time, you can have your own nourishment and you can take care of the animal husbandry as well. This is what the crop of bajra looks like. And then you have ragi, which is a staple food, especially in the region of Karnataka and parts of Andhra Pradesh as well. So ragi is a crop of dry regions and grows well. Look at the type of soil in which it grows. Red, black, sandy, loamy, shallow, black soil. In all types. In the hilly areas, in the plateau regions, also it will grow. So ragi, very rich in iron, calcium and other micronutrients and also fiber. Major ragi producing states, basically Karnataka, Tamil Nadu, Himachal Pradesh, Uttarakhand, Jharkhand, Himachal Pradesh. And in fact, the work which is done by Karnataka to improve and to promote ragi cultivation, that is something which has been noted nationwide and worldwide. In this International Year of Millets, we need to understand how important these millets are, not only for providing that nourishment for that basic nutrition. These millets are important in order to help the farmers withstand the climate change which is happening. Due to climate change, the pattern of rainfall is changing. That is becoming variable. So that is where the growth of these millets, they can help the farmers, they can help them take care of the animals as well, they can help them take care of the nutrition level as well, and they are cheaper at the same time. And millets are not grown now. Historically, if you will observe, even since the time of Indus Valley, millets have been grown. Okay? So that is where we'll end the session here today. And tomorrow we'll proceed further. I hope this session was helpful to you guys. You extracted something out of it. And a couple of questions we'll take and then we'll end it up. Shrikant, can you give the effect of seasonal variation to the rice and wheat? Seasonal variation in what sense? That if you have, let's say, in the coastal area or the region of the eastern part, you have so significant amount of rainfall which is present throughout the year that you don't have to wait only for the month of June to plant the rice. So that is where you have three different varieties of rice depending upon the cropping seasons. You have Os, Aman, and Boro. So Os is basically planted in the month of June and early part of July, harvested in September. Then Aman generally planted in later part of July and harvested in October. Boro is what is planted in the month of December, later part of November, December, and then harvested in Feb, March. Okay. Then Devansh, why West Coast not considered as major area for rice cultivation? You don't have the plain regions which are available. So that is why, because the coastal plains become very narrow in between the Konkan area. That is why in Malabar, that is considered as a major growing area. Some parts in Uttar Kannada region, that is also considered. But otherwise, you don't have that significant area where it can be cultivated. And apart from milk, ragi is only staple food? Weber, I'm unable to understand this question. Rahul, in my area, farmers prior wheat and rice instead of, because they want to earn more. That is the part. We'll come to it tomorrow as well, because if they grow vegetables, they will be able to earn much more than rice and wheat. But they will need to explore markets there, right? In fact, agricultural scientists have predicted this long time back. So that is where the government has been trying to take them to the side of vegetable growth. And it is estimated that if they start growing vegetables, the income can increase by almost 10 to 12 times, provided you have enough storage spaces. For that storage spaces, you need the private entities to come in, because the government will never have the capacity to build storage spaces for all the crops across the country. No government across the world has that capacity. Private players have to come in, provided you allow them to come in. So there are multiple hurdles along the way. Okay. Then Mukkalwar, is inheritance one of the reasons for intensive farming? Yes. The inheritance that divides the farmland into multiple smaller parts. Pranay, millets can be included in PDS. It provides security. Yes, it should be done. Aravali Green Wall project recently announced to counter desertification. Yes, along the Aravali Biodiversity Park, that is where it has been implemented prior. There has been some success, so that is being implemented and replicated across. Do we have a holiday on Good Friday? No. Is it in Lakshadweep Island or our country going to launch plant of water purification? Yes. The desalinization plant, yes. Ragi is complete food as milk, much better in terms of nourishment. Vaibhav. Yes, Sakshi, millets are cheaper. There is still some primitive farming, Deepika, which is still carried out in the hilly tracts, in some small areas in the region of Madhya Pradesh, Chhattisgarh, Jharkhand, and in the northeastern stretch as well. Desalinization is basically the seawater is salty. You remove that. How? So basically, you allow the cold water from lower regions to come in, and that is much lower in temperature. And you have, so by evaporation of seawater, so the evaporates, they are only going to be consisting of water. So those evaporates, you cool it down, you get cleaner water. Pranay, today I read newspaper. It takes more time, but some portion of news not understood. Don't worry. Keep at it. Try to understand those portions that if you have not understood, try to read them slowly. So it will happen. Few of the days newspaper will take more time. It is part of the normal process, my dear friend. Is there any changes happen in UPSC pattern? As of now, no. Is farmers get more profit by producing millets? Not always so, because the market is not very developed, Ananya. Rabi, Kharif, and Zaid cropping, we can describe the agricultural seasons in India. Himanshi, yes. And Devansh, how jet streams influence heat waves. So the prevalence of that subtropical westerly jet stream for a prolonged duration means the onset of monsoon is going to be delayed. So lesser rainfall in those areas. So prolonged heat waves. Okay. So that is where we'll conclude the session here today, guys. See you again tomorrow. Take care of yourself, and any issue that you have, our SMEs are here. You can write to us. You have my mail ID. Get in touch. We'll get back to you. Take care of yourself. Goodbye and have a good night.